Alright, should be a stream and such. Live, whatever, blah blah. For whatever that's worth. And such. And do these little things I have to do and get that over with. Alright, so first we're going to do a Professor Lewin clip. Piece of. And then I'll move on, I think, to something by Wolfram, whatever that actually means. It's well, whatever. Just on particle physics, it was just an interesting, talking through the standard model in terms of its evolution, and you can just sort of get a smell of just how theoretical it all is, and how the evidence isn't overwhelming. It's all just math and theory, math interpretations. And you could imagine there could be lots of other interpretations for what the experiment was showing. You don't have to believe the photon goes through both slits or reverses direction and goes back through the slit and then through the other slit, or some sort of wacky crap. You could believe something simpler and more sensible. Alright, so this Professor Lewin section is just on Newton's second law. I don't really care for the way he describes any of the Newton's laws. I don't care for some of Newton's own language, but, can't do much about it. It's the way people say things. Again, I would argue that if the third law, where the counter force, the reactive force shows up, I would simply argue that it's really a simple process. If I have a pen and I give the pen to somebody else, I become penless, okay? But there wasn't some counter force that made me penless, okay? This only happened. This went from one place to another place. And yes, I become the opposite of what I was, and this becomes the opposite of what it was. But there's only one action. There's not two actions. There's not two forces involved. There's just the one action of moving it from here to here. And so, in my opinion, it leads to a misunderstanding, or a kind of an ugly view of the truth, to say that this, exchange means that two things happened when only one thing happened. All right. So let's play the video.
Now we come to the second law, Newton's second law. I have a spring.
All right, it'd be nice if we had this experiment. Just a spring against a wall, and then you put different sized things on it, and you see how far they go or how fast they go, and but we don't have that simple visual experiment, unfortunately. So we're stuck with these statements.
Forget gravity for now, you can do this somewhere in outer space. This is the relaxed length of the spring, and I extend the spring.
So same difference, extending, compressing. So we'll just assume he compressed the spring instead, just because it makes it visually simpler, I would argue.
I extend it over a certain amount, certain distance, unimportant how much. And I know that when I do that, that there will be a pull, non-negotiable.
And again, it's not really a pull. It's you've stretched the spring, which means you've pushed things into spaces where now their force potential will be different, in the sense that now they are going to get pushed back into their previous condition. So they were compressed by something that pushed them. You expand them by applying a force, and the real environment, when you let go or when you quit applying the force, they get pushed back, because the same compression they existed in still exists. The same stream of energy that was pushing them together is saying, I'm going to push them back together.
I put a mass m1 here, and I measure the acceleration that this pull causes on this mass immediately after I release. I can measure that. So I measure an acceleration a1. Now I replace the...
So the acceleration is a velocity, so plainly. The total acceleration is what he's talking about. So the total velocity will be the end product, blah, blah, blah.
This object by mass m2, but the...
So now he's changed the mass. He's applying a doubling of the mass, let's say.
extension is the same. So the pull must be the same. The spring doesn't know what the mass is at the other end, right? So the pull is the same. I put m2 there, different mass, and I measure new acceleration a2. It is now an experimental fact.
So he just said it. It's an experimental fact. So did we hear all that? Did we get that, dissenters? So just understand the people who saying they debunking me, okay, this is exactly the argument they're countering. So they're debunking Professor Lewin. They're saying Professor Lewin is wrong. Not just me.
But the extension is the same. So the pull must be the same. The spring doesn't know what the mass is at the other end, right? So the pull is the same. I put m2 there, different mass, and I measure new acceleration a2. It is now an experimental fact that m1 a1 equals m2 a2.
So this is just pointing out the inverse relationship. So this is all about momentum, and it's basically just telling you you have to conserve the momentum. And so if you put a smaller mass on, you'll get a bigger, larger acceleration. If you put a bigger mass on, you get a smaller acceleration. Exactly proportional. They have to add up. They're multiplied by each other. It's a complete inverse relationship. You can't, finagle momentum. So if you have a launcher of a bullet or an object, and it launches at 100 miles an hour, a specific weight, and then you cut the weight in half, it has to launch it at twice the velocity. It's no choice. You can't finagle, momentum.
And this product, ma, we call the force. That is our definition of force.
So that's the definition. To say that's the definition of force is to say that's the definition of momentum. Because in these cases, you're talking about total acceleration. You're not talking about an acceleration over a tiny period or any of that kind of crap. You're talking about what's the net acceleration. The net acceleration will be the net velocity because you started with zeros. And you're just simply saying that the mass times the velocity has to, be conserved.
The same pull on a 10 times larger mass would give a 10 times lower acceleration.
Can't make it any clearer, right? He's stating it pretty clearly. There's a complete proportional relationship. You go 10 times heavier in the mass, you need 10 times the force to push it, or you need 10 times, it'll go 10 times less the velocity. They say otherwise. I'm just saying the dissenters, the arguers, the trolls, are arguing that something else is true. So why don't they argue with the physics teachers?
The second law I will read to you.
Okay, it's no point. It's that he's not reading exactly what Newton said, so...
A force action on a body gives it an acceleration which is in the direction of the force. That's also important. Acceleration is in the direction of the force.
Duh.
And has a magnitude given by ma.
Switch now to Fios 2 gig, our fastest internet ever.
Look, I finally cut the cable, switched to Fios 2 gig.
ma is the magnitude and the direction.
So it's in the direction of the force, and so again, the acceleration is the only way you can produce the velocity. So it's clearly just a velocity question when it already doesn't have a velocity. So in this simple experiment where nothing already has a velocity, it's clear the acceleration will have to equal the velocity. All right. So I think that's enough, right? It makes the statement. He's basically confirmed what I've said. And so their argument isn't with me, it is with all of physics, blah, blah, blah. And so they can't keep trying to imply that I am some wacky dissenter when they're the ones arguing for the non-majority fringe, tinfoil hat, okay, interpretation of Newton's laws. All right. So that's, that's all there really is. The rest, he just starts getting into all this other crap that really doesn't have anything to do with these simple dynamics. So, blah, 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 blah. Third law stuff. He jumps right to the third law. I could do some of that. I just to point out I don't like the way he describes it.
So now we will write this in all glorious detail. This is the second law by Newton. Perhaps the most important law.
So this isn't the way Newton wrote it. So again, it's really supposed to be a more clear relationship between force and momentum. That's how Newton understood it. So it's really stupid to say Newton understood it some other way. He understood that the force equals the momentum, the what Newton called the quantity of motion. The quantity of motion being mass and velocity. You use those two ingredients, you get your quantity of motion.
In all of physics, but certainly in all of 801. F equals ma.
So, and then they're later going to turn the A into a per second entity, which means that they're going to end up finding an excuse to later square, the velocity, which doesn't produce anything but nonsense. But anyway, so we won't bother with that. We'll just stick with this simple definition right here. M1 and A1 has to equal M2 and A2. So there's no way around it. If you reduce the mass, you have to increase the acceleration proportionally. Okay, so you end up with the same value of momentum. You have to conserve the momentum. So if your experiment doesn't conserve the momentum, if your spring doesn't produce the same energy each time in terms of its output momentum, then you have to explain why it didn't. You can't just say we're allowed to do that because nature can't finagle momentum. All right. That's enough now. All right. So we'll do some of this Wolfram stuff. Let's see. No comments. Okay. So I can't stay on the subject. Because the commenters just aren't enough of them. All right. So probably have to jump ahead and probably have to change some setting or something else, but whatever.
People used to refer to protons and neutrons as elementary particles.
Okay, let me go back a little.
Sorts of questions saved up.
So, yes, I have submitted my question a couple of times, and he never gets to it, but whatever.
Let's see. Let's look at one sort of a physics question from Jimmy here. In quantum chromodynamics, they ask, what is color confinement? All right, we're going to dive into some...
So he's not going to talk about that first, which is thank God, right? So it's actually going to be a subject that you can almost understand some of them. But yeah, I mean, that's just how silly it gets in the end.
Particle physics was the field that I first got serious about studying when I was a kid. In fact, I even worked on QCD, quantum chromodynamics.
So when he was like 13 or whatever. So that's his history. He was some prodigy, who didn't grow up in some sort of like a normal way. So he was doing, particle physics when he was, 15. Which is fine. But obviously that's kind of a weird maturation, you could argue. And it does seem he survived it without too many defects. Except he's incredibly nerdy. Besides that, there aren't too many defects.
Okay, let's talk about what this is about. So, inside atoms, there are nuclei, there are electrons outside the nucleus. The nucleus is made of protons and neutrons. For a while, people used to refer...
So, again, I would argue that you could sort of understand that it all balances out. So the neutrons are, in fact, electrons and protons. So in the nucleus, you have more positives, more protons than electrons if you count the positrons. I mean the positons, the protons and the electrons total, and just understand the neutrons are neutral because they have both. That's why they're neutral. But they are a composite object, and so it's really just you have a one-fold extra protons in the nucleus, and that's why you have the extra electrons around the nucleus, is because the nucleus is heavily proton bias.
To protons and neutrons as elementary particles, because it seemed like there was, you had a proton, you couldn't split it apart into anything else. But
okay, so I say they should have stayed with that model. It makes sense. It works. You have the charge. It seems overwhelming evidence that charge is the elemental controlling aspect inside of an atom. That atoms do act very reliably to charge. The ions are created that way. The isotopes, all of them. It makes a lot of sense to understand electrons and protons as the elemental charge function, and you really don't need to cut it into pieces. But that's what they wanted to do.
Was discovered in basically by the 1960s, sometime 1950s, 1960s, the protons they're certainly not just points. They have an extent.
So this part is absolutely, you almost say, oh, fuck, you actually had some doubt. So they actually think the electron doesn't have extension. That means it's somehow a singularity or something, that it's so infinitesimally small that it has no presence. Now, I would argue that it was always my sense that these things were interacting with each other. In some sense, they had to be paddles, and they had to be reflecting things. They had to be emitting in a way. And that the only way they could have proportional charge is they had to have a proportional circumference or surface. Because what they were throwing back and forth, whether you believed all of the gluon crap and all that other crap, you had to understand they had to be able to catch the stuff. So this couldn't be infinitesimally small, because then what could ever hit it? Nothing. It would be impossible to hit. Electrons would be impossible to hit if they were singularities, some sort of point thing. So there's no point. Yes, it's mathematically sensible to think of them as terms of their center of gravity, but there's no point in making their center of gravity mean they don't have any substance, because charge, I think, has to work based on the fact that they are the same size. They don't have to be the same density, but they have to be the same size to have equal and opposite reactions taking place between them. You can't have the north and south side of the magnet have the same pull and push if the electrons and protons aren't influencing the same amount of force.
So a proton is about 10 to the minus 15 meters. That's a 1,000 trillionth of a meter across.
So I just never even heard of people talking about their size. Okay, now I heard of talking about mass and understanding the size of these objects based on their mass, but to talk about their physical size, it just seems kind of unrealistic.
They're about 100,000 times smaller than the whole atom is maybe like a hydrogen atom, which has a proton at the center, and then.
So the atom is just the distance between the electron that's affected by the nucleus and the nucleus. But just some of this doesn't make much sense. So if the idea is going to be that it's a million or a billion times difference in size, you'd almost argue, why wouldn't the hydrogen atom collect a whole bunch of electrons? If I could just sprinkle electrons onto a hydrogen nucleus, why wouldn't it collect millions of electrons? Because there's no way the electrons could communicate over those huge distances. They couldn't even know each other existed over those huge distances.
Electron outside, the whole atom is about 100,000 times larger than the proton that's in the middle. So
that doesn't seem very realistic, that you could ever even hit anything on an atom, that you could have anything called a mirror. They say that mirrors, the light only travels maybe 7 atoms deep, 10 atoms deep, on a very good mirror, at the most. So it might hit the first atom, it might hit the 10th atom, but it's not going to hit the 70th or the 90th or the 1 millionth atom deep.
Protons are pretty small compared to complete atoms. Most of an atom is kind of empty space, which is why when Rutherford originally discovered the atomic...
So again, it's just one experiment, really. It's only one way they've tried to detect is that they throw crap at the surface and they say, or substance, and then they say how many of the atoms bounce back. And you could argue that the only ones that bounce back are the ones that hit perfectly on the center of gravity. So you could sort of understand that if I did have, these aren't the best round objects to use, should probably draw it, that if I did bang these two pins, on a pendulum, and just had them bang into each other, and there was no guarantee that I was going to hit on their center of gravity, then the idea of a perfect bounce where it comes right back is going to be a low probability. Most of the impacts I'm going to have are going to create scatter in all kinds of other directions other than directly back out again. So I would argue that that's more likely. The Rutherford experiment is really telling you, okay, yeah, the proton has a center, and it's really hard to hit the center of the proton with a piece of energy and get a perfect bounce back. You're going to more likely get some sort of scatter, and you're not going to see that. So the only thing you're going to see, you're not going to see all the hits. You're just going to see the hits that create a perfect reflection, where all the energy has to come back too. That's the other part. You hit sideways or on an angle, you don't exchange all of the energy. You don't exchange almost sometimes very little of it. So you're not going to get a perfect coming back at you, unless you really do hit that center. Ouch, hurt my finger. Ow. Okay, anyway, so it's a way of interpreting the experiment, right? It's a simple experiment. Throw these little particles at the atoms, see if you can hit the nucleus part, because that's the only part that's dense enough to reflect something back, and you're really trying to hit a proton in the nucleus. And I think this was done with gold. I'm not sure what substance he used. I think it was gold. So he shot this crap at the gold and tried to get something to bounce off the so you could argue, first off, if you're hitting the nucleus, the whole nucleus, it's kind of, hard to know what part of that nucleus you actually hit and how much got diverted trying to even get to one of those little particles. Because obviously as soon as the charged particle you're throwing, the electron or the proton, so as soon as the proton starts heading for a negative, like the electron, it's going to be attracted and bent towards that path, and as soon as it's, so it's going to start bending its path too, which makes it even more unlikely that you're going to get the direct hit you need to create the reflection back out of the substance. So I'm just saying, it's a very, you can't draw too many conclusions. You can just, sit there and do this, speculating about why. It's a tiny percentage of these pieces of energy come back at you. So if you start approximating how big the nucleus is or how big the proton is based on how many come back at you, and you're not counting for the fact that you have to hit the very center of its gravity, then how can you measure its size when you're saying the only time I'm going to see it is when it hits the center? You're really not measuring its size.
Nucleus back in 1910s or so. He did that by shooting other particles at atoms, and found that most of the time the other particles would just go straight through the atom because they were kind of going through the empty space in the atom. But just occasionally they would hit the nucleus and then they would be deflected a long way. And that kind of pattern of doing experiments, if you shoot something.
So it wasn't the wrong way. Just recognize it really did have to come pretty close to back out. Okay, the instrument couldn't detect it from any direction, and if it did that, we would have those, those images of where it came back. What angles it came back.
Thing at an object, and you see, does it just go straight through because there wasn't anything there, or does it hit some hard piece and bounce and kind of bounce off in a very different direction. That's a sort of pattern of doing things that was repeated multiple times.
Right, and it has a limited ability to tell you anything. So they did see it get scattered coming out, and it was a lot harder to detect the scatter going in because you're trying to push stuff into it. So, but regardless, I'm just saying it doesn't tell you that much, because you can understand that the only time you're going to get enough energy coming back is you're going to have to hit it pretty close to a hard. You can't glancingly blow and then expect a reflection. So there's lots of conditions you have to meet before you even get a reflection back. And to get a reflection back that has enough energy to get back out of the substance requires that it hit pretty much the center of its mass.
So, okay, it became clear that protons were not point particles. So the question is, what are protons made of? And that wasn't clear, but then...
Okay, so he's saying it was clear that protons weren't point particles. Where did that experiment happen? So that didn't become clear to me, and it still isn't clear to me. But they're certainly not point particles in that they're not infinitesimally small. They're a particle of a certain size. And I'd say the size is proportional to their charge, because frankly, charge is how they interact with... This guy believes in virtual photons. I mean, he thinks there's virtual, energy moving between protons and protons. So he must get the idea the thing has to have a size, or it couldn't possibly be capturing virtual anything.
The most significant thing that happened, this was around 1970-ish, early 1970s, was people did the same kind of experiment that had been done with atoms by Rutherford when he discovered the atomic nucleus. They did the same kind of experiment on protons. And what they did was they shot electrons, high-energy electrons, at protons. And they wanted to see, would the...
So, again, it's hardly the same experiment, because you could hardly say I have a wall of protons and I'm going to bounce energy off the wall of protons. So, obviously, the experiment has to be done in a completely different way, because it's hard to make a mixture of protons. It's hard to make a bottle of protons.
Electrons just go straight through, or would the electrons hit something hard and be bounced in a very different direction? And what was found was that much of the time, the electrons would just go straight through, but occasionally the electrons would hit something and bounce in a very different direction. There's a phenomenon called deep inelastic scattering. And so
the fact that they scatter isn't a surprise. Now, the question is, okay, is the angles they scatter at? And so then the geometry becomes just an argument about if the thing is already moving, if the thing I'm hitting isn't standing still, and you could argue that there's no way they made a bottle. Let's say they made a bottle of protons, okay, something that's more made out of nuclear bits, I don't know. I mean, it's hard to imagine exactly how they could purify this bottle of protons, but regardless, just say something has more protons than anything else in it. So it has a lot of protons lingering about. The fact is, you wouldn't expect them to not be moving. So now you have to calculate, well, if this already has momentum, the proton, it could have momentum this way. It could have momentum this way. It could have momentum in lots of different ways where it has a velocity. And you could hit it when it's going with you, where you're not going to see much. Or you could hit it when it's coming against you, where you're going to see a lot. Okay, in the sense that you'll have an energy increase. So whatever you're throwing at it will come back at you with more energy. And that same rule is for side to side. If it's going this way and it hits that side, then it's going to have less energy. If it hits this side, it's going to have more energy. And so I think that could explain why, yes, the scatter is not going to be the same as the scatter if the protons are just sitting there. But if the protons already have energy, they're going to affect the scatter by giving it more energy or giving it less energy. And yeah, that could look like something different hit it. But it's just the fact that, yes, it's going to be different each time, because each time the proton's going to be moving in a different direction.
The idea was that it's sort of inelastic, because it doesn't just sort of, well, not quite the right word really, but that was what it was called. It doesn't just sort of bounce off Well, okay, the reason it was called inelastic scattering had to do with thinking about whole protons hitting each other and sort of bouncing off as complete protons, as opposed to sort of shattering into pieces in some sense. But in any case, the thing that was discovered was you shoot high energy electrons at a proton. And by the way, one of the things that was being assumed there is that while protons are extended objects that have
a lot of things are being assumed, obviously. So again, he's by saying extended objects, he's just saying they have a size. Yeah, well, can we all say duh? I mean, really, they think there's some doubt that the proton has a definite size, and its size has something to do with how it interacts in the universe. Yeah, I think so.
Definite size. Electrons were thought at the time, are still thought by many people, not by me though, to be sort of point particles that don't have any extent. So they're a good sort of probe of, what's inside the proton.
So to me, that makes absolutely no sense, right? Because you're just saying, how could the charge of the electron and the charge of the proton be equal? That is opposite but equal in magnitude. If the electron is this point thing that doesn't have any substance in the universe at all, any profile, and the proton does. I mean, it doesn't make any sense that this would be the mechanics, because it's so lopsided and so irrational in a sense, because you can't make that come out to having exactly the same force potential, the same impact in opposite directions. How can they have the same impact in opposite directions if they're so different in their structure?
Oh, you shoot this thing that's basically a pure geometric point, doesn't have extent. You shoot it at the proton. You use that as a probe of what's inside a proton. So the big thing that was discovered was that there were inside the proton, there were some kind of hard bits that would occasionally cause the electron to scatter in a very different direction.
So they're basically saying that the hard bits are the thing causing the different kinds of scatter. So I would argue you'd have different scatter whether the proton is moving away from you. You'd have a different scatter if it's moving towards you, and a different scatter up, down, left, and right. So that's where you get strange and up and down quark, is merely because the proton has its own momentum, and it's going to give momentum to your electron through the interaction.
Those things were initially called partons.
And they're not going to reflect in a pure reflection anyway, because the two objects are attracted to each other. So you're going to have to understand that the speeds and the momentums are going to be even more messed up, because the more on center you hit it, the more energy you get from charge, and the less off center you are, the less energy you're going to get from the charge. And the leaving potential is going to be also affected, because the two things are attracted to each other. When the reflection happens, they're going to be pulling away from each other, and they're going to lose a little bit of their energy because they have to essentially oppose their own charge attraction.
By my friend Dick Feynman, actually. This kind of the things that are the parts of a proton. Okay, so it became clear there was substructure inside protons. It wasn't clear what it was.
Okay, so they say it became clear. Clear to who? I'd say it's clear to 4 people in the world at the time he's talking about. Okay, it's their theory, their little pet. And somehow this idea, okay, this one interpretation out of what could have been 15 to reasonable speculations is the chosen one. It's the chosen fable. So they become Jesus freaks, and the rest is history, so to speak, in the sense that they somehow win the day with this fable. But it's just a story. I don't think it's a reasonable story, and it certainly wasn't a highly evidenced story. It's nothing to say it was proven, not even close to it was proven that protons are made out of quarks. It wasn't anywhere close to proven.
Okay, and another part of the whole sort of world of physics, there was this thing called the quark model, invented by another person I knew quite well, Murray Gell-Mann.
Right. So he's just retelling the story now, and what he should point out is before they did the experiments, or who knows which one happened first. A theoretician decided to say, I can make a model of protons and I can put these quirky things in it and I can explain some experiments. Maybe. I don't even know how many experiments he was doing. But yeah, so the theory is part of the pre-existing. It's like they're looking for their virgin birth, so they go out and try to find some woman having an illegitimate kid where there's no chance they're going to find the husband, the father.
Along with another person, George Zweig, who I also have known for many years. But in any case, that was invented in 1962, maybe, and maybe 1960. Might be off by a year or two.
Yeah, so it's 10 years before the scatter experiments, right? I don't know.
But in any case, the idea... Okay, so let's talk about the quark model. The question is... first point is protons were discovered as sort of what were originally thought of as elementary particles. Later on, neutrons were discovered. Both protons and neutrons are sort of known pieces of an atomic nucleus. It was a big question of how does the atomic nucleus, how is it stuck together, so to speak? Because all protons are positively charged particles with an electric charge +1 in some units. And if you put together lots of like-charged things, they repel each other. So
to me, the whole key, and they never said this when I was a kid, so I'm sure the physicists believed it, but they didn't say it. There was no public acknowledgement of it in any way. So I guess I'll draw this little tiny bit. So there was nothing to... When they said neutron when I was a kid, they really just said it's this neutral thing, okay? They didn't tell you... Oh yeah, when it decomposes, that is, if we can put it in some quiet place, it turns into, protons and electrons. A proton and an electron. Who cares about the anti-neutrino? That doesn't seem to be a real thing. But anyway, and so that's all they said. Neutrons were neutral. They didn't give you any further insight into any aspect of what the hell a neutron was. They just said it's some neutral thing. And so obviously that changes everything once you establish that the neutron is, that's good enough, frankly, is an electron and a proton. So say if this is going to be a neutron, and then you understand that the neutron is really just a proton, and an electron. That's all it is. Well, then the nucleus has these extra protons. So, it's not that hard to figure out that I could keep adding the extra protons in places, and I could end up creating a composite object that obviously has a lot more, positives than negatives, because I put the negative in the first negative in the middle. And then I put the other negatives, in certain geometric locations. All right. And I can essentially create an object that has this 2-to-1 relationship that'll end up having twice as many, of the positive features as it'll end up having the negative features, all right, just by, certain geometrical rules. And then you can sort of get the idea that, what's really happening here, what you're really doing by creating this geometry, is that you're making different material atoms, and it's all these geometric rules will dictate it. And what you're always going to end up with is some relationship that's pretty close to 2-to-1 in terms of how many protons you have to electrons. It just has to do with where you stack them. So how you stack the electrons, and you've got 3 dimensions to work with, by the way. So there's obviously places, all right, where you can stack these objects and end up placing, more and more of them. Like for every electron, you could argue there's at least 2 protons that could be in these positions where they're attracted to the electron, and their repulsion isn't strong enough here, okay, to wipe out. They just have to be at a further enough distance to keep this repulsion from pushing them out of connection to the thing they're attracted to. So I'm just saying, as long as you understand, the model can be 2 different ways. You can have a model where the electron is in the middle. Well, you can barely see that. Or you could have the same idea and just have the proton in the middle and the 2 electrons. So you can have these 2 choices. And obviously inside the atom, this is the choice. There's 1 negative for every 2 positives. And that works. And you don't need any strong force. The explanation for why the protons are close to each other is because they're attracted to these electrons. So you could just call this the neutron, and you call this the proton that you've attached to a neutron. So in the atom, you have a more stable neutron, hydrogen atom, and you're basically just attaching another electron to it. So anyway, that to me, that's the more logical way to understand that it's just geometry and there is no strong force. You don't need a strong force. All you need is an electron in between 2 protons, and you've blocked the ability for the protons to repel each other. I mean, that simple idea is all you need.
Inside an atomic nucleus, you would think, oh, all these protons, which all have the same charge, they're all going to just repel each other and the atomic nucleus is going to fall apart. But that doesn't happen. And the reason it doesn't happen is because of this thing, it's called the strong nuclear force, that is...
So it's just a made-up force. So so instead of solving the problem by understanding that there's some mechanism that negates the repulsion between the protons, there's some player, and the obvious player would be an electron, and the obvious thing to be providing the electrons are the neutrons. The neutrons have an electron in them because you know that, because when you decompose them, that's what they produce. So you already know the neutron has the negative in it. It has the electron built into it. So you know it's in the nucleus. The nucleus isn't just all positive. It's just more positive than it is negative.
A strong force that holds protons together, but it's a short-ranged force. So if you, for something like electrical repulsion or attraction force, if you have 2 objects that are a distance r apart, then the force goes like 1 over r squared. It's an inverse square law, same as the inverse square law of gravity for electrical kinds of things. But the strong...
Yes, but for magnets, it's a cubed law, and for this, they're claiming it's whatever, some insanely huge number law.
Strong nuclear force falls off much more rapidly than that. When you get beyond a distance of, pretty much around the size of a...
So let's understand that the only reason why there's a squared law is because of a really explicit and rational geometry. There's a squared law because what you're doing when you move away from an object, okay, in terms of your size, is you're moving away in 2 dimensions, okay? So if you're going that way, you're leaving this thing in these 2 dimensions. And that's why there's a squared law, is because you're spreading now. The force is less likely to hit you, right? If you're in a position and you're moving away in this dimension and this dimension. Okay. Because the moving dimension's irrelevant because of the fact that, the other 2 dimensions are the ones that are relevant, and the one you're changing is the one you've changed. But the other 2 see the change in a sense. Okay, so the point is that obviously if you're a paint spraying machine and you're spraying paint, you can understand that as this paint goes out, there's less and less likelihood it's going to hit a specific dot that I keep moving further and further away. All right. And it's moving away in both dimensions. It's getting further away in both dimensions. So that's why there's a squared law. Now for magnetism and the cube law, it gets more complicated. That's really just an artifact of the fact that if you could understand that you had two guns and one was spraying blue and one was spraying red, that at a certain distance it's all going to be purple. So that's what's destroying the facts, is that you're spreading it in the two dimensions from the two guns, but the problem is the two guns are crossing each other, and once they cross each other, now you just have purple. So you're undoing everything the other side is doing, and so now you have no force because you have no pure blue and no pure red. You just have purple, and you're saying you can't detect purple. I mean, all of this fits, frankly. So we'll go to this comment because, it can't be that far off the subject. Okay, so is Newton's third law saying that if you move a pen with a scale, push a pen with a scale, not only does the pen experience a force, but also the scale measures the same force? I don't think the third law is dealing with the fact that the force has to move through the objects. So an interesting experiment that Professor Lewin does, and I think it's at the end of this video, frankly. I mean, it's an experiment that lots of physicists do. Yeah, here it is. Okay, so the idea is he has I mean, he's a grown professor.
Nothing wrong in
You
life,
just think he'd know that you really can't do this crap. I'm just going to let some company decide to put a bunch of tacky commercials on my goddamn physics. The fact that MIT gave him rights to all of these videos was very generous, considering, Lewin got into a bit of a sex scandal. And he should have some appreciation for that. So anyway, so there's this block. Can you see that? Yes. Held up by two threads. You can see this thread, but no, the real thread holding it is this little tiny thread. So he's replacing the threads in this particular case. Well, I might as well play this through. No, there's too much baby talk in it, frankly. I mean, he's doing a stunt for the audience. He's not really doing, it's one of his, stunty experiments. So the idea is this: he has a thread below the very heavy block and a thread above. And the fact is, if he pulls the thread quickly at the bottom, then the bottom thread will break. And if he pulls it really slowly, puts the pressure on slowly, he's obviously adding more pressure to this block. He's making the block heavier. So the heavier the block gets, the more likely that thread will break first, because they're equal threads, right? So whatever pressure he's putting on here is added to this block, and then obviously this thread will break first. But the simple truth is, if he breaks it quickly enough, that is, he applies the force quickly enough, it never gets to the block. The block never even knew it happened, so to speak, in a way. And so it never got to this thread. This thread didn't know it actually happened. It happened so quickly. And so he's basically confined the force over such a tiny amount of time that it never had time to get to the other thread. And so it broke this one first. There's probably a way of doing it where you can break both of them at the same time, but that's really, you'd have to be really clever, lucky, whatever. All right, so back to the question again. Is Newton's third law saying that if you moved the pen, I don't know what the pen is, with a scale, oh, you're talking about my pen, not only does the pen experience the force, yes, but also the scale measures the same force. You're just transferring it from one thing to another, so it's just a progression of the force being moved. But anytime something's sitting on a scale in gravity, it's constantly feeling that force because it's a constant pressure. It won't be a constant pressure when you're moving the pen. So when you first hit the pen with the scale, you might deflect the scale, right? And then it'll give it back unless you keep applying an acceleration. So you have to keep applying the acceleration to keep the scale deflected. So in gravity it's more obvious. you can put the weight on the scale, and all you're doing is transferring where in space the Earth pushes back. So instead of the Earth pushing back on this platform here, the Earth pushes back on the platform here because you put more weight on it. Let's see how to say that. But I don't really see the connection to the third law. I mean, the third law is just more about the equal and opposite reaction. So it has more to do with, like I tried to explain, that there's really only two kinds of ways you transfer. Okay, the transfer of you hitting something, and therefore you give it to it and you don't have any. So the Newton's cradle, right? Complete transfer. This thing loses it, this thing gained it. There was no opposite force that took it away from this. This one just gave it to this one. It's, it exchanged it, it gave it away. So that would account for all the friction and all those kind of things. Those are just exchanges. One thing has a difference than the other thing. They're doing something different. And when they contact each other, they're going to share their differences. So one's going to lose something, one's going to gain something, however you want to look at it. But there's no conflicting forces. There's no extra force that shows up to give the other guy what he lost back or something. There's no opposing force. Nothing opposes motion. There's no inertia problem. Nothing opposes being given energy. And the other example is the explosion. So you know that when you're going to expand or contract something, it's usually going to end up, unless you engineer it to be in just one direction, it's going to be in all directions. And that's the explosion. It's just saying, okay, I'm sending energy in all directions, so obviously left and right are going to have energy going both ways. So it's not really an equal and opposite reaction. It's the same explosion, and it's just going to send momentum in both directions. So it gave energy to both sides. The bullet got energy from the explosion. The gun got energy from the explosion. There wasn't any communication between the gun and the bullet. It was just that the explosion happens to happen in both directions, and therefore both directions got energy. So it's just more about the symmetry of explosions. That the nature of an explosion is symmetrical. That's the default. Okay. I don't know. It's a question. I mean, I don't know whether I satisfactorily answered your question, because it's a little bit in between, laws. It's more like halfway between the second law and the third law, I think. Anyway, moving on.
Of a proton and atomic nucleus, they're sort of all comparable in size. If you get much beyond that distance, the strong nuclear force...
They're all comparable, almost comparable in size. I mean, I think that's one of the things we kind of know in physics, is that all this stuff has to be really reliable in its size. So you couldn't compose these atoms. You couldn't make the geometry. If protons came in various sizes, there's no way you could have the perfection of atom to atom to atom to atom all being the same. I mean, come on. And the only way you can break the atom or change the atom is you have to pull in a whole new proton or pull out a whole electron. You can't change it by saying, well, I have skinny electrons in this nucleus, or I have fat protons in this nucleus. They're obviously exactly the same.
Has fallen off in strength tremendously. So in the 1930s, it was realized sort of how do you account for the strong nuclear force? What actually is it? Well,
so it seems a weird, all the way back to the 30s now, and we're going to account from the strong nuclear force, which really isn't a strong nuclear force if you know the neutrons aren't actually neutral. So if they knew in the 1930s that the neutron was made of an electron and a proton, wouldn't it be kind of obvious that you just put the electron in the middle and you can have two protons stuck on it, or you put the proton in the middle and you can have two electrons stuck on it? And then if you go into 3 dimensions, obviously you can have 2 electrons this way, and you could have 2 this way, and you could have 2 that way, and they would all be equal distant from each other. So you can just basically create a hexagon, and use 1 electron and use 6 protons.
One thing to say is, when you think about electromagnetism, electromagnetic forces, force of electrical repulsion or magnetic kinds of phenomena, the way to think about what's going on there is you've got this charged particle, like an electron with an electric charge, and
So to me, the thing to think about is whatever you think these objects are, you have to recognize that they have an exactly inverse effect on each other. The electrons repel each other with the same amount of force that two protons repel each other. And that the proton and the electron's attraction is exactly inverse to that force. So the force opposing between two electrons is exactly the same as the force attracting between two protons. A proton and an electron. And that you could, you can create this perfect balance where you could have two magnets next to each other, and they're basically saying, we're comfortable with this. We're not going to get any closer. We don't need to go any further away because it's a perfect balance.
What's the way that one thinks about it in kind of this theory of, for example, quantum electrodynamics, the quantum theory of electromagnetic processes, is that there are virtual photons being exchanged. So an electromagnetic...
So he's he's basically recognizing that, yes, it's an atmospheric effect, okay? That you have an object, and that there's this energy bouncing between it. And the closer you get, the more energy there is, in the sense that the more impacts there are. So they're basically acknowledging that aspect of the theory, but they never apply it from now on. He'll just say that, and the rest of everything they talk about will have nothing to do with it, because they're still doing the point particle thing. They're still doing this infinitesimally small electron interacting with this almost infinitely big proton by comparison. And how the hell could the virtual photons, they're going to go into some, bent space and change their size?
So photons...
But the very idea of a virtual photon, you're right there. You're saying, you mean your physics requires you to not even say a speculative photon or a maybe photon or a possibly maybe photon? You're actually going to say the word virtual? Why would you do that? I mean, that's just like invisible. Oh, it's an invisible photon.
Are the particles associated with electromagnetism? When you have a beam of light or something like that, you can think of it as light waves, but you can also think of it as a stream of photons, a stream of particles of light. And normally when you have just...
So obviously I would say it's not a stream of photons, it's a stream of the composite elements that make a photon. A photon is made out of bits of dots and dashes, you could argue, right? It's really just dots, and there's separation between each other. And you're just saying, yes, there's a stream of dots, and when you put three dots together at the right frequency, and then you bend them with a little bit of polarization, that is, you have them like musical notes on bars, okay, so they're streaming at a perfect speed, they have a frequency, and they have a polarization, that's a photon. But the little bits, okay, aren't a photon by themselves. They make photons.
A light beam or something where it goes a long distance, you've just got photons that are happily moving through the vacuum or whatever, moving through, and they're just, the photon is just exists and
Right, and so then they also know that, no, they don't move happily because somehow they get redshifted over great distances. So then you could speculate kind of obviously, oh, well, yeah, the universe isn't actually a perfect vacuum. There are these little blobs of hydrogen. You could call them neutrons. There's little neutrons, floating about, a little bit of residue, a little bit of fog. And those photons have to, now and then, go through the little transparent pits of fog. And every time they do that, they lose a little bit of their distance between each other. They get a little further and further apart, the little tiny bits. And that would explain the redshift, and it would explain that you don't need to start talking about the universe getting bigger, because it doesn't need to now.
And keeps going, so to speak. But there's another way that photons can work, which is they can be emitted by, let's say, one electron and then absorbed by another electron. And that can happen.
So my argument to that would be is no, that doesn't happen. The electron is a player in the creation of a photon, but it takes more than one. It takes more than one atom to produce a photon. It takes more than one atom to receive a photon. It can only receive parts of it, so it only receives a portion of the momentum of the photon. And if it receives it in the right sequence, that is, you hit the ground with the bullets in the right order, then you will add energy to the system. And if you don't hit in the right order, you won't add energy. Okay, so it's just being on resonance with the atoms. You're going to push an electron in one place, and that's going to push the electron with the other place. The virtual photons are going to push the two electrons. The other electron's going to move. And what you're really going to do is, while it's moving, you're going to hit essentially behind it, another atom behind that electron, and add more energy to it. And then if you can hit it a third time, you're going to add even more energy to it, and eventually you add enough energy to ionize the atom. And that's it. But that's the photon. The photon is not some... Photons are gigantic. Their wavelength, okay, is 1,000 or more atoms. Their polarization is 1,000 or more atoms. How can something flying through space with a gigantic polarization and a gigantic frequency hit a single electron? How could it possibly stay in the same place? You're arguing that it can travel thousands of atoms with the electron staying in exactly the same place to be hit again by the same stream of energy, or the same mile-long wavelength. How does a mile-long wavelength, right, of a radio wave hit one electron that somehow stays in exactly the same place to receive a mile-long wavelength? Does that make any sense to you? Doesn't make any sense to me. Doesn't seem very likely the electron's in exactly the same place in space. It's moving on the Earth. It's spinning through the galaxy. It's doing all of this motion, and yet you're going to hit the same exact place. I don't think so.
In a very short time. One electron emits a photon, and then pretty soon that same photon is absorbed by another electron.
So it doesn't absorb whole photons. One electron does not absorb a photon. More than one electron produces electricity. So my second argument would be, electricity exists. You know that electricity is how you detect a photon. It has to create an electric reaction for you to say, hey, there was a photon, because here's the electrical reaction I got that demonstrates it. We know the electrical reaction has to do with a cascade of electrons across atomic structure, so you're just basically saying the photon must duplicate what electricity does, which is deform atoms, okay, in a sequence where it's sharing pressure, basically. The pressure at one end is high, the pressure at the other end is low, and it moves in that way through the wire. And you can put impediments in the way and make the wire get hotter and hotter, or you can do different things to change how well that happens, but it's a cascade, and so the photon has to be causing the same kind of cascade. It has to be duplicating the cascade that electricity is. And how could a single particle do that?
And when the photon is emitted, if it can kind of give a certain the photon can carry momentum. So you've got these two electrons, they're just going along, they're not emitting.
So again, key point. So why are we talking about weightless photons? If it has momentum, it has mass, so why are we talking in any other terms? And the mass really is made out of its constituents, the little bits. So you have little bits of quanta, as Einstein would say, energy quanta. The energy quanta, you can vary its momentum by increasing how many hit, or, that's increasing the mass, or you can increase it by increasing the velocity. Now, it all moves the speed of light, we understand, so you really can't change the velocity. So all you can really do is change how quickly, in what amount of time, what mass hits. And that changes how much energy it can have. So yes, high frequency light has higher energy because there's more mass hitting per second. Even though it's moving the same speed, there's more mass, there's more quanta in that photon.
Any photons, they just go in straight lines. But if
So
those
we got
electron,
that part. We got that part. This whole particle physics is straight lines. So we should say, yes, everything's straight lines. There's no sign of a wave in any of this stuff. All the vectors of energy are straight lines. So why are we pretending waves have something to do with this? It's all straight lines. And if you want to draw a bunch of equidistant straight lines, if you want to say they're midpoints, or I can make that look like a wave, well, yeah, maybe you can. You can make it look like a wave, but none of the elements of that wave are anything other than straight lines. I mean, you could take a peacock's feathers, and you could see, look, all the spots are here, and all these spots are here, and all these spots are here, and you can make it look like a wave, but it's not a wave. It's individual feathers, and it's individual dots heading in a direction. You're missing the obvious part and paying attention to the emergent part. The elemental part is the straight lines. That's the element of charge. That's the element of energy in the universe. It's a bunch of straight lines. The emergent part is something that looks wavy.
If the momentum of one of those electrons is transferred through a photon to the other electron, that transfer momentum will kind of kick the other photon in a certain direction.
Right. So if an electron is moving on the side of a slit, okay, right, and you shine light through, and the electrons are moving on the side of the slit, they're moving in and out of the atoms, okay? They're not moving sideways or this way or that way. They're basically, the motion would be in one direction because the mass is in that one direction. So they're popping in and out of the surface. So they can either be going this way or they can be going that way. Now the photon comes through. Now the photon is made out of these elements, these quanta, these little bits. So one of the bits might be hidden electron that's going out. That means it's going to get deflected that way. And it's not really going to get deflected. What it's really going to do is it's going to be absorbed by the electron, so its momentum is going to change. And the new momentum of the electron pushing that way, okay, pushing, it's just going to end up reflecting force, and it's going to reflect it sooner than it would have been reflected. It's going to collect all the force there, and it's going to reflect it, compress it, and send it in a direction. So now the compression was going this way, and now the compression is going to be going that way because the electron had momentum this way, the photon had momentum this way, and the two momentums are going to end up to a new direction. And if the electron was going back, then obviously it has momentum this way, and it's going to send the light that way. So it's going to scatter the light in those directions, the directions of the slit pattern. It's going to make the double slit pattern.
And so you can think of the electrical force of attraction as being through the exchange of a series of photons between these electrons.
So obviously it can't be photons because photons are technically huge, gigantic polarization, gigantic wavelength, way too big to fit inside of an atom. Can't fit, can't work in there. The little force bits can work in there. The little force, the little quantas of force are what are trapped between the protons and the electrons. Well, between the protons and the protons and the electrons and the electrons.
And so what's happening is that there's this sort of exchange of momentum, which is kind of transferring force from one electron to the other and causing it to have, let's say, a force of attraction between the electrons or a force of repulsion between the electrons. That will be the immediate thing for electrons.
So that is just so, like, back of your hand cheap answer, right? So he's trying to explain why there's attraction and repulsion, two fundamentally different elemental functions, because there's some little photon doing something, right? Well, an attracton would be exactly the opposite of a repulsion, right? In the sense that if these have to be made out of something really elemental and simple. So the fact is, I can't take simple ping pong ball analogy and say, okay, you have a ping pong ball and you have paddles. Well, that certainly does make repulsion understandable, right? The further away I am, the less times they hit, so the less times they exchange momentum. But the closer I bring the paddles, the more times they exchange momentum. If I say the ping pong ball has infinite energy, that is, it just never runs out of its velocity, it's always going the same speed, then every time it hits, I get a certain amount of momentum. So you can understand the closer they get together, the more momentum is pushing them apart, the more energy. but that doesn't explain attraction. I mean, and especially doesn't explain the inverse attraction, between the electron and the proton. So you have to come up with some other theory. And I found that, yes, you can reduce it to simple elements, but you still have to retain, you have to basically concede there are two kinds of charged matter, and there's two kinds of charged force. And those two kinds are oppositely interacting with each other, and that explains it. So there's two kinds of interactions, two kinds of force, and two kinds of matter. That solves the problem. See if there's any new comments. All right, empty feeling. I'm saying this so I understand better. Is it wrong to view reality like a grid, and electrons move in one direction? They move any way they're pushed, and interact other things like photons, and can move and be reflected in that way. Everything in the universe nothing can eat energy. So there's nothing in the universe that just eats energy forever. Obviously it would just consume all the energy in the universe, and that would be it. So everything, like the Earth included, has to absorb energy and readmit it, or it would just keep getting bigger and bigger and bigger and bigger and consume the whole universe. So the electrons and the protons, you have to think in the same way. They're just reflecting their environment. So all they can do is reflect the energy, or they can absorb it for a period of time. That is, it can push them somewhere. But eventually, when they stop moving, they have to stop moving because a counter force released that energy. So all you can do is hit something, cause it to move. You're absorbing the force, you're holding it. You can hold it temporarily by actually moving. So you're holding it, and then something comes the other way, and this reflects and that reflects. So you gave it all back, and now you're stopped again. So the energy's always doing something. So if I said there's that quanta of energy that makes up photons, and that's the only energy in the universe, the argument would be is that energy is either free, that is, it's flying as a photon from one place to another, or it's doing something where it's moving freely, or it's pushing a piece of matter, an electron or a proton. So there's only two things the force bit can do: fly freely, or be stuck for a while, to an electron or proton. That's it. So the force tells the matter where to go, and where the matter is decides where the force is going to be, because it's all really just reflections off the matter ultimately. Ultimately, the force will be reflected off the matter. It sticks for a while, and then ultimately it has to be released. All right. Third grid where there is an X and Y axis, 3D grid. Well, there has to be a Z grid also, not just an X and Y for 3D, but whatever. Don't want to really argue it, but the point is that it's just a field of energy going the speed of light that never stops. And the only thing that can happen to that stuff going the speed of light, those BBs, they're in a sealed universe, you could argue, and they just fly through the space in straight lines in all directions, and all they can do is hit a piece of matter, and push it in a direction until some counter force, another BB, hits in the opposite direction and causes it to be reflected. And that's all that's really happening. So matter moves much slower than the energy, and that's what's creating the deficit we call gravity. So the Earth is being bombarded by a bunch of energy. The energy goes through the Earth. It moves electrons and protons as it goes through the Earth. It's slowed down while it's doing that, and so a little less energy comes out than went in. And that's gravity. All right. Like your simulation you have been working on. Yes, exactly. The simulation simulates what I'm describing in terms of the interactions between electrons and protons. I would argue pretty perfectly simulates it, frankly, and let's see, it should be here somewhere. Where the hell is it? There it is. It always ends up, nicely creating these balanced conditions for the electrons and the protons. They will drift about and always balance the attractive and repulsive force. And blah, 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 blah. So, yeah, you can see that. So, yes, it works perfect. Perfect. Nearly perfect. He hasn't, haven't quite got it all finished yet. Time limitations, blah, blah, blah. The menu's now working, so I can increase the number to 5 and play around with the speed and do things. But it's still not perfect yet, so until it's perfect, I won't publish till perfect. Well, more perfect, let's just say. Oh, you can't see that very well, but there are 5 of them in there now. And such. Anyway, yeah, just throw that in. Let's see. Great, thanks. Are you comfortable with the history of experiments? Okay, so this is the tricky part, right? Because they talk about experiments, but the experiments were never done, right? So you have a ton of rhetoric about the 2-slit experiment, how they did these detector experiments, and they did this, and they did that, and none of that shit ever took place. So you have to be very careful when somebody says the history of experiments. Yeah, not really. Showing electron protons have inverse square repulsion attraction. I'm just saying the inverse square is just a byproduct of spherical symmetry. So anything interacting in the world that would have spherical symmetry has to create an inverse square law. It's just the obligation. And then you could argue that, let's see, I mean, it's so much easier to see it if you think of the Earth reflecting energy. Well, then you could understand the inverse square law easier than I think thinking of it penetrating and then coming out the other side as an inverse square law. But the point is any difference you make would be a difference that is in all directions. Because of the spherical circumstance. So it's a light bulb producing light from a location, and you're just saying there's a certain number of photons coming off the light bulb. So, I mean, a light bulb is doing the inverse square law. It's exactly the same gravitational law that the light gets dimmer by. So it's exactly the same thing. So you're just saying any point source or any spherical object is going to produce the inverse square law. So there's nothing remarkable about the inverse square law. It was all over the place already. Like I said, they made a big deal over Newton and Lodge were arguing with each other about who discovered the inverse square law, and it was almost like, I think that was discovered centuries ago because it's everywhere. I mean, it's in water waves. It's in everything spherical. It's already got the inverse square law built into it. Spherical in the 3-dimensional sphere way. You obviously have to include all 3 dimensions to see the inverse square law. All right. It would be interesting to learn how they separated electrons and showed this. So they don't need to. All they have to do is create a charge representing an electron. So you just create an object that has a negative charge, and you create an object that has a positive charge that's spherical. And those objects will behave as if they were electrons and protons, and they can make it do it strong or weak depending on how strong or weak you put the charge on those objects. So I could just take any 2 spheres and I could charge them. And I can charge them with a high density of charge and make it really easy to see, or I could deal with a low density of charge and make it harder to see. But I mean, you're just going to see exactly the same effect. So magnets are behaving very much like the little magnets that the atoms are creating. So you can understand that there's almost a perfect analogy. A big magnet is almost a perfect analogy for the little magnets that atoms become when they have an imbalanced number of electrons on one side and then protons, when they get misshapen. Okay, when their electrons go further away from the nucleus, or when they get closer to the nucleus, they're basically turning into a little magnet. And you could metaphor them and analogize them, and they'll behave just like big magnets. And I think that answers the question. We'll assume I did. And such. So, thank you for the comments.
electrons, which are both negatively charged, two electrons both negatively charged. There's sort of a photon emitted from one, and it kicks the other one away, and that's sort of the force of repulsion. And this is happening.
So that would be a really good statement if you went just that little bit further and saying, yeah, it's like two ping pong paddles. And if I have energy trapped between them, there's no way for it to escape without causing motion. So in my analogy, the only difference would be is the ping pong ball doesn't not stick. So there is a point where the energy will stay with one of the objects and be pushing it until it gets reflected by an opposing force. So it'll push until the opposing force shows up to stop that from happening. And then it'll bounce back and hit the other one and stick until it pushes it out of the way. So you can understand it's not a perfect repulsion in the sense that it doesn't just keep bouncing back and forth. It literally has to push the objects away from each other. But you can understand that everything that gets in the way, anything that's opposing the push, just creates another push in the other direction. So when this one's pushing in this direction, right? When I'm a piece of force and I'm stuck to this one, I'm pushing this one away. This one isn't doing anything, right? But this one's getting pushed away. The opposing force shows up. Well, now the opposing force is going to force this to stop pushing. But the trick is, it's going to send it to the other side, and now it's going to push the other guy. So no matter what you do, you're still going to have a lot of energy pushing away, even though they're sticking. It's still almost the same amount of energy because every time the opposing force shows up, you just make the other object move further away. And so when this one stops, this one goes. When this one stops, this one goes. So you can sort of get the idea that the pressure is still going to mount and it's always going to keep pushing things away until there's enough counter pressure to equal that back and forth pressure.
Between two electrons that are nearby, you have all these photons being emitted and absorbed, and that's happening all the time. And that
so you can kind of know it can't be happening all the time, all these photons being emitted. It's not photons. It's energy quanta. Okay, and maybe all of the energy quanta between two electrons might equal one photon. I mean, it would be way too much energy to say, okay, there's 1,000,000 photons trapped between two electrons. You know, not likely.
That's a way of understanding what causes electrical forces. Well, there's one tricky thing here, which is those photons are not the same kinds of photons quite as the photons that you would have kind of in a beam of light. In a beam of light, photon starts off, it just keeps going forever.
All right, so there's just no point, right? There's no point in changing the definition of words all over the place. I mean, photon is a describer of all of the little quantas of energy through the whole electromagnetic spectrum, so it's just kind of bogus to say we have different kinds of photons. You know what I mean? Elementally. It's elementally the same thing, it's just a frequency. That's all it is. That's what the spectrum shows you. It's just a change in frequency.
In these photons that are being emitted and reabsorbed, the photon only kind of exists for a limited time. And the way quantum mechanics works, the uncertainty principle.
Okay, so that's all mush, right? Because we know nothing lasts for a limited amount of time. Everything's eternal. The stuff in the universe, the matter bits, the energy bits, it's all eternal. That stuff doesn't just do anything for a limited amount of time. It just goes somewhere. So you have to say it right. It goes somewhere. All right, let's see, another comment. With the simulation you have, maybe, if possible, it would be great to have a 3D model. Well, it actually can be converted to 3D, but it's the limitations of, creating enough force pressure are already difficult in 2D. Okay, so, I'm just saying it gets a lot harder for the simulation to function in real time, and so then you have to basically record, a length of time and then play it at a higher speed and all these other different things. But anyway, fine. Where you could move around and see them bounce back from all directions. Yeah, well, having them fly into you and fly away from you and all that stuff is a nice visual effect, but I just mean, frankly, the idea is to prove the model. The idea isn't to entertain. But okay. I'm not saying it's not worth doing, and I'm saying that it's already, like I said, it is already built in, frankly. It's just that it's not a priority. So where the hell is it? I don't know why I can keep losing my vision. All right, so it's somewhere down here. We have 3D, end angle, reset, start, 3D. There it is. So, okay. So I'll turn 3D on. Whoops, wrong one. That's the stupid background color. We didn't want that. This is a little unintuitive, frankly. I mean, the moving device is further away, so you might be able to see some of that 3D kind of crap, but you can see it slows everything down insanely. But yes, it will eventually be a 3D model, but obviously that isn't going to happen tomorrow. Well, it's not obvious it's not going to happen tomorrow. I'm just letting you know it's not going to happen tomorrow for sure. Let me turn that off because it's really killing my computer. Wrong one. I have to do this one. No, it's not working. We'll just refresh and that'll kill it. Okay. So yeah, 3D is a little bit dangerous. Yeah. It hurts my computer. All right. So back to the comments. Let's see. Of course, that will take more work, I suppose, to create. Yes, exactly. That's right.
Implies that when a photon exists only for a very short time, the standard sort of properties of a photon don't need to be there. So an ordinary photon is a zero mass object. It goes at the speed of light. It has zero mass, etc.
So what are they describing? It's not even a describable object. It's some zero mass. So first I'm supposed to believe in something that has momentum but doesn't have any mass. It doesn't make any sense. It's just some little sparkly angel. So they should just say sparkly angels fly around and push things in the universe. I mean, it's such a mushy, non-mechanical piece of elemental function. Where, to me, yes, it is understandable that the universe could be made out of BBs, okay, and then potato chips. And the BBs just move the potato chips around. I mean, that's understandable. Their mush, not understandable.
When these photons are being emitted and reabsorbed, because they exist only for a very short time.
So again, all these rules, these are magical photons that only exist for a very short period of time. So even though photons travel from 13 billion light years away and they come flying to us over 13 billion years, they last for 13 billion years. These photons, they don't last. Come on.
They don't have to act like zero mass things. They can act like non-zero mass things just for that very short time. The longer the time, the closer.
Yes, the frogs can put on a turtle suit and, they can fool everybody because they look like turtles. I mean, it's just, I'm sorry, but why don't other people find this like laughably funny? I mean, this is just they're just making up any kind of crap, okay? And yeah, I did the same thing. I mean, I sat here for 10 years drawing pictures of swirling things. Like, okay, I make the electron swirl, and then the swirl, the swirl waves come off, and the swirl waves do it. I tried all kinds of shit. But just admit that this is just shit, and this doesn't work. This is not working shit. When the shit when you have to resort to, well, yeah, the frogs just wear turtle suits, then you're really not getting it right. That's not going to be the right answer, that the frogs put on turtle suits. That's not going to be the right answer.
So they have to be to zero mass. And in the language of particle physics, they're usually referred to as being off their mass shell, and the reason it's called that is because you imagine that the momentum of this may be more technical, but you imagine that momentum is a vector, and that vector can be kind of the length of that vector defines length of the momentum 4 vector, which is a combination of energy and ordinary momentum. The length of that defines the effective mass of the object. And so that length, when you have these, there's a sort of a shell.
I mean, momentum is by definition mass and velocity, and they just keep, they just keep wanting to put frogs in turtle suits. I mean, it's terrible.
Of vectors which are all the same length, and if the thing isn't, if it isn't at that length, then it doesn't have the effective mass of the thing is not its normal mass. So anyway, these so-called virtual photons, these photons which exist only for a very short time, those are the things which are the what's really exchanged when there's electromagnetic force acting from one object to another. Okay, so that's how it works for electromagnetism. So a chap...
Right, so he had nothing to say basically about how attraction works. That just explains repulsion. It won't explain attraction. So the only way you can create attraction is you have to somehow negate the force. Somehow you have to make the force go away, and that's what I did. You make it go away by just making the electron force inert to protons. That is, it can't push a proton, and the proton force can't push an electron. So, whether they're triangles or squares, and, you can make them different shapes, you can make them different colors. The point is the two forces have something distinctly different about each other, and one of them is inert to the other. And once you do that, okay, then you can create this idea of an object always radiating electron force and another object always radiating proton force, no matter what goes in. So for an electron sitting in the universe, the proton force comes in, and it comes out in electron force. So it's getting pushed around by the electron force. The electron force is causing its motion, and the proton force is just being converted into electron force, which means the proton force will push an electron force, but it has to be a different electron. So I can make proton force turn into electron force and then push an electron away. So I could have electron, electron, and proton, and I would actually be making more electron repulsion, because all of the proton force is going to be converted to electron force and make the electron twice as repulsive.
Called Hideki Yukawa, back in the 1930s, had this idea that maybe strong nuclear forces were associated with the exchange of another kind of particle, and that particle became called the pion, and or earlier the pi meson, but nowadays the pion.
So they invent the particle first, and then they just go out and they make the experiment produce one. That's all that's really taking place. All the particle physics is just saying we have a bunch of noise that comes out of our accelerator, a bunch of all kinds of crap, and we'll just look for it. And, it doesn't even matter whether it's an aberration, it only happens one time in a million times or one time in a billion. Doesn't matter how rare it is, doesn't matter. We're just looking for it. So it's like the people go looking in space, and they're just going to say, let's go find the smiley face galaxy. And they find one. Let's find Richard Nixon. Eventually we'll see a picture of Richard Nixon, in space, from the big field telescope thingy picture. Eventually we'll have enough data where they'll be able to find Daffy Duck, and they'll find all kinds of stuff. And we'll be right back to astrology, right? We'll be right back to the idea that there's gods in the stars and blah, blah, blah. And we'll all pray to Daffy Duck, the Daffy Duck galaxy.
And a pion is a particle that is, well, it is, again, it's something where a proton is going along, and it can emit a virtual pion, which is then absorbed by another proton, and that exchange of the virtual pion can lead to a force from one proton to another. It happens to be always an attractive force in the case of pions. And the pion, unlike a photon, is not zero mass. It has a mass of about 1/10 the mass of a proton.
So it's an attractive force. So this is another gluon, another graviton. So the pion travels to a proton and somehow creates an attractive force. Doesn't push. Creates pulliness.
Proton. And the fact that it doesn't have zero mass means that when you separate protons further away, it's not obvious this will be the case, but this is just how the math works out, that the kind of force of attraction between protons has a piece that is just like in electromagnetism, 1 over r squared, but has another.
Okay, so the attraction between protons, obviously that statement doesn't even make any sense at all. All right, so he's saying this strong force is this now being converted into an attraction force somehow. So somehow you're pushing the protons into each other, even though they're supposed to be repulsive, and you have some force. So the force is the strong force, or it's the pion, whatever, pull force. So they're just changing names for this entity that's supposed to be making the protons get close to each other, when my simple argument is the electron does it. The electron fixes the problem. Stick electron between 2 protons and you have fixed the problem, because both of the protons are attracted to the electron. And if they're on opposite sides of each other, they can't see each other, so they don't know we're supposed to hate each other.
Piece, which is an exponential that's basically a version of the mass of the pion multiplied by the distance. So it's e to the minus mu r over r is the typical formula, and so a thing with a tenth the mass of the proton has.
I mean, I can't even imagine how convoluted. I mean, this is so bizarre. This is, as a kid, I played chess a little bit, a tiny bit. It's sort of an interesting game, okay, but it's an investment in time to play it well, right? I mean, to really become some sort of guy who's going to beat everybody. You can beat 70% of the other people pretty easy, but, those 30%, forget it. And to go to the next level requires you to do this, to sit there and fill your brain full of all this weird sideways bent thinking. I mean, why would I do that? I mean, it just amazes me that people are so invested in, they have to know all these layers of fable to finally get to the 3-dimensional 3 pig story that actually has Goldilocks in it, and the 3 bears do live right next door. And, Little Red Riding Hood Wolf also is the same wolf. He's in both, and you have to know all of these connections. And you're like, why would I waste my time on this complex structure of storytelling? I mean, it's just layers and layers of bullshit, and I can't even imagine. Well, I remember the formula for that. Wolf is 3 feet left, right, up tree. Yeah. In story 97 at 48 minutes.
Sort of effective distance associated with it that's on the order of 10. I don't know. It's a distance comparable to the size of a proton, comparable to the size of an atomic nucleus. And so what happens is, at these very short distances, there's lots of pions being exchanged, but as you pull the protons further away, the pions, they're because of, for reasons that are, they're easy to explain mathematically, the number of pions that kind of can be exchanged goes down very rapidly. And so that means that there isn't a force of attraction between protons that are far away, but if you make them go close together, then there's this big force of attraction that comes from the exchange of lots of these votes.
Right. So the strong force has been converted from a strong force that was pushing them together into a strong force that's pulling them together. Completely inverse to the actual physical circumstance that we know exists, which is they hate each other's guts. So somehow there's just protons sitting there, and there's some special force that's saying to them they must be now attracted to each other, when it's completely the opposite of their basic elemental function, which is to basically be red hot, 2 hot things, and they're going to repel each other. I mean, it's just so made up, and it's not even a good story. I mean, it's Papa Bear didn't have a head, Mama Bear has no legs, and Baby Bear is a frog in a turtle suit. I mean, the whole thing doesn't have any continuity. It just amazes me that people can say, oh yeah, I totally get it. I don't know how you could totally get any of this crap.
Virtual pions. There's virtual photons being exchanged between protons that are pushing the protons away. There's virtual pions being exchanged that are pulling the protons together. So in any case, this beyond protons, there were and neutrons, pions were discovered as these things that are part of the strong nuclear force. Now, I should explain something.
Yeah, so they really weren't discovered as in, oh, there's a pion, we saw one. Yeah, none of that happened. All they saw was something moving, in a cloud chamber. They saw a little streak that popped out of nowhere, And because the other part that created it, the energy that created it wasn't visible. It wasn't charged energy. It didn't create ions, didn't create a cloud, so you didn't see it. And so they're just making up the invisible part and saying, well, this happened and that happened invisibly, and that caused this to happen. So they're just making up the story. They can make any number of invisible lines to decide what made the visible line.
The things get more complicated. There aren't just pions. There are a whole collection of these so-called meson particles, which are sort of available to be exchanged between things like protons. So, for example, there's a thing called the rho meson.
All right, so the good news is soon he's going to say, and none of these things last more than a millisecond. So none of these imaginary little fake things last. So you could argue that these are just impulses of energy. They're just an amount of energy. They're an amount of the quanta. And the amount of quanta pressure moves about, and you could call it a muon when it's this much pressure, or when it's this much pressure, it's this much pressure, that much pressure, this much pressure. You call those things different things, but they're not things. They're energy. And that's all they are. They're just a kind of gamma radiation, you could argue, or something. And so you're calling that gamma radiation a particle. It's not a particle. It's not a thing. Okay, it's just an amount of energy. And the ones that are about this much energy you can call a pion, and the ones that are about this much energy you call a muon, and this much energy you call some other name. But that's what they're doing here. They're really just calling energy, clumps of energy, particles. And they're really not particles.
F meson, a whole zoo of these kinds of things were discovered mostly in the 1960s. One feature of these things is, and this is again a sort of a tricky thing of quantum field theory, these different particles are characterized by having a certain mass. They're also characterized as having a certain spin. Roughly, that is, you can think of them as little tops that are spinning around, except that in the case of an electron, you might think it's a zero-sized top, but yet it still has an angular momentum. It still has some sense in which it has...
Yeah, zero-sized top that has momentum, and now it has angular momentum. So it not only has linear momentum, it has rotational momentum, that is its own little substance, is somehow its own mass of electrons and protons. What's its mass made out of? Somehow its mass has rotation, and somehow it's going to convey that rotation energy to other objects and cause them to rotate. And how that rotation could accomplish anything in that universe of individual objects is beyond me to understand. I don't see how that would mean anything, except it could waste energy. It couldn't produce an effect except to hide energy. So that's all this spin is really using for, is there's just another way for them to mathematically tie things up by saying, well, we don't have enough energy in our outcome, so therefore we spun the object, and that's where the energy is. That kind of thing. So they're just saying, oh, yeah, it does an A, B, D, and they're making up a C story, okay, that was, okay, the C is stuck in this spin. Comments, please. Don't want to do this forever. Okay, so yeah, we're winding down for this video anyway, I think.
A kind of a rotary, it's not really a motion, but it's some rotary characteristic, so to speak, that's usually called spin. We can talk about quite separately.
It's really not spin, it's really not movement, it's really not rotation, but we'll call it spin anyway. I mean, just charming.
That's a whole separate discussion, what spin really is. We're beginning to really understand that in our physics project, actually. But anyway, all particles are characterized by having a certain spin. So, for example, electrons have spin 1/2. Protons have spin 1/2. This is that's a thing. Photons have spin 1. Pions have spin 0. Gravitons the analog of photons and so on for gravity have spin 2. And it turns out...
No, it doesn't really turn out. So you can sort of understand about photons is they're so reliable, right? They do all this consistency, so perfectly consistent, so, it's just, there's no room for this idea that I can have, well, this photon has spin and this photon doesn't. Come on. This isn't a real thing.
That these different spin numbers say a lot about the general properties of how a particle behaves. So, for example, particles with half-integer spins, so-called fermion particles, have the property that they obey this thing called the exclusion principle that says if you try and stuff lots of these particles in the same place at the same time, that won't work. You can't do that.
Yeah, well, why would I think I can shove anything in literally the same place, okay? This thing is occupying the space. I can't put another pen in the same space. So why do I think that's possible on the subatomic level? Why do I think things can occupy the same space? Why would I say that's... Yeah, let's go with that theory. Let's put that in the foundation, even though there's no real good reason to do it. Let's start with that as a starting point, that we can put things in the same space. I mean, that just is so... fuck. I mean, how did that get to being a default? Oh yeah, it just seems like that's the only way it could possibly work, is things must be sitting in the same space. Oh, come on. Oh, just so not pleasant. All right. I'll be off on my way. Thanks for the information and stream. You're welcome and such. Alright, Penrose. Oh, fuck, Penrose in the ass till dead. Anyway, is the only high-profile physicist. He's not, no. Frankly, it's not physics, in my opinion. Alright, I've heard that said that he can't make sense of particle physics. Well, there you go. But they say that about their quantum mechanics, too, just as a joke. Oh, yeah, who can understand? It's so silly and so fucktarded. Why would anybody believe this nonsense? But we're just joking, because we really believe it. We believe it so much, we'll burn down your fucking house if you dare say anything against us. Fuck this. He wasn't prepared to go into detail, but interesting take from a Nobel Prize winner. Yeah, Nobel Prize won for crap. I mean, frankly, this is all such a pile of wooey crap. Shit. I mean, every bit of it. It's not like this is just one silly story they're telling. I mean, you could hear him. He just goes on and on and on. 3 bears, 3 pigs, 3 blind mice, 3... I mean, it just keeps going on and on and on and on and on and on. He just keeps expanding the gingerbread village. I mean, there's no end to this Oz. It just goes on and on. Layers, 3-dimensional Oz. I mean, it just goes on and on. I mean, there's gremlins in the gremlin world, it's that kind of thing. The gremlins have gremlins. And the gremlins are really gremlin-y, I mean, it's just, there's no way, you can't even metaphor how pathetic it all is. In terms of it's so made up. And it's, like I said, there's nothing wrong with making up the stories. That's all you can do at first is guess. But these guesses suck. These are really shitty guesses. Why did my house blow down in the tornado? And the good guess is, because God doesn't like me. I mean, shit. No, that's the bad guess. Particle physicists discovers one phenomena that their model predicts and carry along 10 other unseen phenomenon. Yeah, well, whatever. That's your theory of how they make it up. I don't know. This seems to be a 1 to 100 ratio, not a 1 to 10 to ratio. But, and the confirmation is, so it's like the confirmation of Bigfoot. All you need is a guy in a gorilla suit, and that's good enough. That pretty much proves it. I mean, you could just take a picture of your basement floor and you could say, see, there's Sasquatch in there. Yeah, it's a little foggy, a little blurry, but yeah, right there, that little blob, that's Sasquatch. That's about as much evidence as they have. But it's so unfundamental, it's so unelemental. I mean, why do they think the small universe is infinitely more complicated than our universe? Even the galactic universe, it's insanely more complicated. And you're saying, how could the elemental universe be more complicated? That just doesn't make any sense. I mean, you would think this universe would be so fucked up if there were all these particles to fuck up with us. All this stuff to go wrong. All this stuff to do something rare and unusual. And particle physics depends on, yes, Ke is the origin of all of their energy problems. So they do their math, they get a silly number for the amount of energy there should be, and that's why they have to invent neutrinos. The entire invention of a neutrino was because they had an energy deficit in their equation, right? They weren't getting enough energy out of the reaction, okay? They split the atom, there's not enough total energy, so we must invent a particle that's carrying the extra energy. Because their kinetic energy theory obliges. Anytime you go from a big thing to small things, you have to create too much velocity. Okay, your velocity ends up being more than it was before because you're squaring it. The proportion of velocity to mass changes. So as soon as I go from big mass to less mass, I'm going to automatically be forced to create more energy. So if Ke theory is wrong, all this family tree of gremlins collapses. Yes, exactly. That's my whole point, is that this is a big mistake in physics. This ain't a little one. This ain't getting plus and minus wrong. Okay, Ke, kinetic energy, is a gigantic flaw in reasoning. And that flaw has just been built on and built on and built on, and it's so irrational and so stupid and so obviously wrong. It never takes 4 times more fuel to go twice as fast. Again, something so obvious they haven't proved. In 350 years, they haven't proven the theory, and yet they have it as the foundation of all their physics. It's really just so stupid that they wouldn't shore this stuff up, that they aren't really seeking the proof. And you argue that why aren't they seeking the truth? Why aren't they seeking to prove it? Because they're like Brozo. They don't want the truth. I mean, if they believe it takes 4 times more fuel to go twice as fast, why wouldn't they do the experiment and show us it takes 4 times more fuel to go twice as fast? I mean, it's just such an obvious thing you do. I mean, if you're going to say, I'm the Messiah, right? If I'm going to say, I'm Jesus, then now we're going to say, well, let's see you walk on the water. You know, we can film it and videotape it, and, you know, we can put it in 3D, a scope. You know, we can do lots of shit. We can have, like, vibrating chairs in the theater and all kinds of stuff. You know, we can really make a show out of it. So they have all this advanced technology, and yet they won't take a picture of something being bent by the sun's gravity. You know, they have these gigantic $10 billion telescopes, and they won't use them to prove anything that is elemental. So it's really just not a question, though. Particle physics depends on Ke. I mean, all particle physics is done with that stupid mv squared. They don't use momentum. And where NASA just uses momentum. That's the funny part. So NASA is not doing particle physics. Alright, and Wolfram didn't talk about this, but doesn't he believe all these gremlins he talks about exist in their own separate fields, and they are all disturbances of fields? Fields seem like nonsense. Yes, well, I think he gets to some of that, but I can't recall, frankly. But obviously he's a guy who thinks math is really fun and interesting. And so to him it's all a mathematical model, and the physicality doesn't mean much, where to me, it's kind of the opposite. The math is a nice little thing to prove this and that, but to formalize it, to simplify, but there aren't a bunch of 5s and 7s floating around in the universe. The only part of fields that makes sense is the fact that the universe is densely packed with this energy shit. So, in a sense, there's a giant field of energy, and the energy can be in different compressions and rarefactions. It can be in different separations. The little BBs can be thinly packed or densely packed. And so, in that sense, considering it a field of energy is reasonable, but to think that the field acts is stupid, because the only thing that acts are the individual birds in the school of birds, right? The flock. And the school of fish. The individual fish have all of the energy and the momentum, and they're all acting as individual characters, but the interesting fact is they all individually create a pattern. So it's patterns, patterns is a fair way of describing field effects, I guess you could argue. But it's all just made out of discrete bits. It's a very bitty universe. Lots of little bits. Force bits, matter bits. And then the empty space between them. So I might play the other half. I don't know. It's just that it's, it does get tedious because it's all just, it's not a fascinating story. It's a convoluted, complex, bizarre story. I wish it just had gremlins in it or something, But it has George, Fred, Michael Gremlin, only has one leg and he has to hop on 2 canes. It has all these different characters. You have to keep track of all these different characters. Alright, 2-minute warning, I guess. Something like that. Let's see how we did today. Number-wise, probably 8, 9. Yeah, well, whatever. It's always the same lately. Gots to do better than that. But what are you going to do? Can't bribe people to do it. It's got to be somebody willing to, actually discuss physics. Discuss the experiments, discuss the interpretations, discuss what is a reasonable description of the reality. And the fact that you can't find that person is really, that just doesn't make much sense either. All right, last chance, people. All right, so we'll call it a day and such. So till the next time and such and so forth. Yeah, 2 hours, right on 2 hours. So that's a good time to quit. All right, your strategy for your theory is to build it up with logic at first. I don't know if that's my strategy. My strategy was I would say something brilliant and people would say, holy fuck, you're right. And I'd be done. Okay, this shouldn't have taken this long. I'm saying absolutely brilliant things and people are just calling me dirty, stinking, lousy names for it. And then that's the part that's just too fucking irritating. Okay, and then support it with the simulation and math. Yeah, well, the math is just so fucking irrelevant, frankly. The math was already done by Newton. Yeah, force equals energy equals weight equals pressure equals heat equals everything. Yes, force is the motion, okay, and as I've simply put it, what's the math for? Yeah, the force hits you, it sticks, or it reflects. Those are the only two choices. It either sticks, causes you to move, or it reflects and causes you to slow down or stop. Those are the only two things that happen. So what's the math going to be? I mean, the math is ABC math. I don't need any of this convoluted fucking abstract math. But anyway, yes, the simulation I thought would impress some people, but it doesn't impress anybody. They don't care. So, I mean, I don't know. You tell me. I'm saying these people... Obviously, this is the conspiracy, is that people are belligerently stupid. They're not stupid because they're trying to find the truth and trying to understand. No, they're stupid because they want to believe in their woo. Okay, there's some wooey thing they need to be true. So, because some asshole wants to believe in a wormhole, he has to believe in mv squared because without mv squared, there's no fucking wormholes. That kind of bullshit is going on here. This is about people's attachment to a piece of music or something. This is just them defending, their fish wife or something. I don't know what the fuck this is. This is personal problems. This has nothing to do with logic and reasoning. If it had something to do with logic and reasoning, I would be done. I would hand it over to the nerdicals and say, here, nerdicals, finish the job. Okay, I've given you the right foundation. Now build the correct universe on it because I've given you the right foundation. Now build something interesting. All right, have you found anyone to come on to these live streams? No, I can't bribe them. I can't pay them. I can't do anything. I can't embarrass them to do it. You can't do anything to get any fucking cunt on the internet to stand up and make a rational argument. Okay, all they do is some clown video. They won't respond to a single thing I say or a single thing I argue. Are people too scared? They're too belligerently addicted to their own little putrid gingerbread world that they want to live in. And they think they have the right to fuck the truth hard and nasty to get what they want. I mean, the very fact that they won't admit their physics is preposterously under-evidenced. I mean, any reasonable person should be able to admit, I wish we had a lot better evidence than this shit. I wish they redid the editing experiment. I wish they showed it taking 4 times more fuel to go twice as fast. I wish they won't even say that. That's how fucking corrupt and dishonest they are. I wish they did the double slit experiment in a vacuum. I wish they did, all the things they should have done by now that they haven't done. I don't think being in a vacuum will change anything, but I'm just saying there's all kinds of experiments that just haven't been done. I mean, the very fact that you can't find on YouTube you can't find on the internet, frankly. I've looked Google and Bing and different places, try to find some website that you can't find the simple experiment where you take a 1 mass and you compress a spring the same amount, and you put a 1 mass on it and shoot it, and you compress it the same amount, put a half mass on it and shoot it. You can't even find that experiment. I mean, it's just so bad. So, yeah, it's just, it's just so bad. I don't know. You can't even, I can't understand how it could be this bad. I just can't I'm so disappointed with intellectuals. I'm just so disappointed, because I really thought with intelligence came integrity. Came a real desire to do everything right and fair. Those concepts would be deeply ingrained. Hathaway had some of that. I mean, he wasn't being, that's why it's just disappointing, because I know Hathaway, these arguments are now good enough that Hathaway would be like, yeah, they really should have the fucking evidence. He was already saying that, but I mean, he would really be saying it now. But I'm just saying that, yeah, the people are just so, it's like, what the fuck? It's a waste of intelligence if people are so dishonest and so cheap in their the way they argue for their positions. It is just Photoshop. It is just, any cheap way to win. It's disgusting. All right, this is going to mean nothing. M1A1 equals M2 A2. Yes, the two things have to have the same momentum. Okay, is the force being applied to each object? Yeah, it's the same force being applied, and the argument is if you have a less mass, then you have to have greater acceleration. And if you have more mass, M2 is greater, then A2 has to be greater. I mean lesser. Because it has to equal what went in, so to speak. The force. The force in has to equal the momentum out. That's what the equation says. That's what Lewin said. So you want to keep perverting it, go ahead. But that's not what he said. It's not what he's shown. You're just being completely dishonest to say that Professor Lewin was saying anything other than half the mass, twice the speed. It's exactly what he was saying. So it is only saying the force acting on each is equal. It's not an equal force is the whole point. The acceleration is twice as much or half as much, depending on which one you're talking about. The acceleration is a real thing. You can't just sit there and say the acceleration is the same, even though it's twice the acceleration. Or it's half the acceleration is the same as twice the acceleration. They're not the same. All right. Oh, I'm just going to block you. But because of the faster acceleration, the force act on smaller mass for less time. So again, he keeps saying it's less acceleration. The acceleration is an amount of acceleration. It doesn't matter what time it is. It's an amount, you shithead, and it's a total amount. It's the net amount of acceleration. It's the net momentum. It's the net force. It has to be the net acceleration, douchebag. Oh, you're just such liars. Is not the same as 2 velocity. He clearly used acceleration. Okay, so this is the cop-out. The cop-out is they're going to pretend the acceleration isn't directly related. So so if I play the clip of him again saying half the mass has to be twice the velocity, or he says twice the mass has to be half the velocity, should I play it over and over and over and over again? I mean, you people are just such goddamn fucking liars to pretend he was saying something other than, yes, the force equals the momentum. You have to increase the velocity. If you increase the mass, you have to decrease the velocity. If you decrease the mass, you have to increase the velocity. Of course, that's what he was saying. He was talking about the conservation of fucking goddamn momentum. Oh, you people are just such liars. Such weasels. He clearly used acceleration. And what is acceleration? Is it magical? No, acceleration is exactly the velocity in this case. It starts with zero acceleration, zero velocity. The acceleration will be its velocity. Oh, you're just such slime. See, this is the slime. This is how desperate they are. They're clinging so desperately that they will pervert Lewin's words. They'll change what he said. They'll do anything they can. They'll cheat in any way possible. So you're just molesting. No, you're molesting Lewin, okay? Go ask Professor Lewin what he thinks the velocity will be at the end of the experiment. And he'll tell you exactly what he said when he did the fucking experiment. Half the mass, twice the velocity. He said the fucking goddamn words, you fucking liar. All right. He didn't say what you think he said. Yeah, he did. Exactly that. Of course it's the net. There isn't anything else but the net. No, it's not the net. Of course it's the net. If what he's talking about, it's a closed system. He'll tell you all that stuff. Of course it's about the net. There's no fucking, accelerated this way, and then accelerated that way, and then accelerated this way, and accelerated. No, there's none of that bullshit. It's one fucking acceleration in one fucking goddamn direction. He made that clear. You're just fucking cheating so desperately. You have no clue what you're talking. No, you have no clue. Acceleration is not a velocity. This is the stupidest. This is, you must be as dumb as a Puro. What the fuck are you talking about? All velocities are made out of an acceleration, you fucking idiot. Acceleration is not net acceleration. All of the equation is based on net products, okay? None of it was about this minute, this second. It was about inputs and outputs, motherfucking cunt. And you know it and I know it. It was about the end product of the experiment. It wasn't about the first millisecond or the 17th millisecond. It was about what the fuck was the product of the experiment. That's what conservation of momentum is about. It's not about any one fucking moment. It's about what the fuck happens after the experiment takes place. What do you have in the universe? You have the same fucking momentum. That's his argument. To say his argument was something else is just being a lying weasel. All right. So fuck you. Whatever that could mean. The net, you don't know what net acceleration is. You can't figure that out. Okay. No, I'm just explaining basic facts. You are. Acceleration is instantaneous rate of change. What does that mean? Instantaneous rate. What does that fucking goddamn mean? Acceleration is measured over any distance you choose. You can choose to measure the acceleration over 10 miles. You can choose to measure the acceleration over 2 seconds, a millisecond. So more lying nonsense. All right, what you are talking about, acceleration being made of velocity. No, I'm just saying accelerations cause velocities. That's the only way you get a velocity is something had to accelerate you. Does not mean it is velocity. Yes, it does. Okay, no, it was about acceleration. So this is just more lying. Okay, so this is their lie. Okay, they can't accept that accelerations are velocities. That's all it is. 30 miles an hour, 60 miles an hour, 70 miles an hour. That's an acceleration. Okay, and velocity. Yeah, you can have 30 mile an hour velocity, 60 mile an hour velocity. The change is always going to be described as exactly the same substance as the stuff you made it out of. So if you lost 30 miles an hour, you lost 30 miles an hour in acceleration. It's said the same way. It's the same goddamn quantity. One of them isn't squared. Okay, per second. Nobody says 60 miles an hour per hour because it's irrational bullshit. You're lying to say you don't understand what a net outcome is. That you're saying there's something other than the outcome that Professor Lewin was comparing. On one side of the equation is the input, and on the other side of the equation is the output. Essentially, he's basically saying you always have to have the same output. You can't have some other output, so no matter what I change, I have to have the same fucking output. The same fucking momentum has to be conserved. He's saying overtly, you have to conserve that force. You can't come up with some other number, so you can't sit there and pretend, well, I changed the acceleration, it's twice the acceleration, but twice the acceleration didn't produce any product at all. It didn't change anything. Twice the acceleration doesn't mean twice the speed. Of course it does. Oh, instantaneous. Look, he's going to tell us what instantaneous is. It's a special little calculus concept. No, I think the word existed long before calculus did. Acceleration is instantaneous rate of change in velocity. It's baby talk. It doesn't have anything to do with fucking goddamn reality. That's just a lie. The acceleration is calculated by a unit of time, and that time is arbitrarily chosen. So it's just a lie to say acceleration is always about some instantaneous event. It isn't about instantaneous events. It's about events that take a unit of time. So just lie some more. Nowhere in the math is the instantaneous function used. Okay, the word t is used. T for a unit of time. Liar. Big difference. You have to ignore these details because you don't serve your purpose to confuse people. Now you're the one being an advocate for your fucking Jesus fable. Okay, yes, and acceleration is units of meters and seconds. Yes, seconds squared, which is just pointless nonsense. Yeah, and Lewin will do an experiment later that I could show again where he makes free momentum because of that moronic squared. I didn't say Lewin wasn't an idiot. I'm just saying don't tell me you're not disagreeing with Lewin, because Lewin's telling you overtly that the acceleration doubles when you half the mass, you double the acceleration. That's overtly what he said, and you're telling us that twice the acceleration doesn't mean twice the speed. So you're saying something so fucking idiotic, okay, and you're putting words in Lewin's mouth. Lewin didn't say anything about, oh yeah, but that means it only goes 1/4 of the speed. No, he clearly stated it. It's conservation of momentum, and if you decrease the mass, you have to increase the fucking velocity, and that's what he says later in the same goddamn video when he clearly says nature can, fuck with kinetic energy, but nature can't finagle momentum. You're finagling momentum. You're saying you don't have to conserve momentum. All right, you fucking lying sack of shit. That's what you're defending, is a concept that no physicist agrees with. You're absolutely opposing what Lewin is saying. You're opposing what he was arguing. You're opposing his math, clearly. You lying sack of shit. All right, so there's no point in reading this. And I and others are not disagreeing with Lewin. Yes, you are. Where's your conservation of momentum? How did you conserve the momentum? If the half as mass object doesn't go twice as fast, how did you conserve the momentum? Where did it go, fucker? Lewin certainly didn't draw any example where, oh, well, yeah, the momentum went back into the spring. It went into the earth. He didn't say any of that. Why wouldn't he say that if that's what he thinks happens? If he thought the momentum goes back into the earth, why didn't he say that? All right, I'm not strawmanning you. You're the one fucking lying about what Lewin said. If acceleration does take place for a different time. So again, it keeps saying there's some sort of, he can create this different time arbitrarily. Then why didn't Lewin put that in the equation? Oh, there's this time differential. The acceleration only happened for half the time, so therefore the acceleration didn't create twice the velocity because it only happened twice the half the time. Where did he say that? Where did he indicate that's true? He was arguing for the conservation of momentum. He was saying the momentum has to be the same. You're saying the momentum doesn't have to be the same. I mean, you're obviously disagreeing with him. You're the one creating the straw man. Okay, if you have the acceleration for half the time, again, where was that put in there anywhere? Where was that argument made? That the spring doesn't have enough time to put the energy into the object, and therefore the acceleration won't be twice as much because the energy never got into the object, because somehow the spring couldn't do it because the spring didn't have enough time to do it. Where is that any part of the argument? Well, you can put it in capital letters. He was talking about energy conservation. He was talking about the conservation of energy, you liar. The fucking video is conservation of momentum, you fucking liar. Amazing. So I guess I have to replay it and replay it and replay it. And just, and see if we can find that little piece, okay, where Professor Lewin made an indication that when he was talking about acceleration, he was talking about something other than velocity. Because that's exactly what the acceleration causes, is the velocity. Force is momentum. Again, you can't conserve anything if you don't conserve it. So Newton clearly stated that force is momentum. So you clearly don't like Newton. He clearly said you want twice the momentum, you put in twice the force. But yeah, see, this is the desperation. They just will not, So he has no experimental evidence to defend what he's saying because they won't do the experiment, simply. I mean, why wouldn't this experiment already exist? Why wouldn't somebody have tested springs by now? No one has your conception of acceleration and force. Well, Newton did, and Descartes did, and Galileo did. So lie some more. I mean, yeah, none of you morons understand it's that simple. but certainly they did, and certainly they got a lot of right answers because they did. Now, I would argue that NASA does know it too. NASA knows that it's only momentum leaving their spaceship. Okay, if they shoot an exhaust out, all they have to do is measure the mass of the particles and the velocity of the particles, and they'll know exactly how much energy they lost. So NASA certainly knows the truth. So to say no one has my conception is just absolutely wrong. NASA understands. Yeah, force is momentum. All right, so you're just lying, okay? He doesn't believe in conservation of momentum, this asshole, okay? Marxism. So when Professor Lewin overtly says it's a real thing, you have to conserve the momentum, nature can't finagle momentum, this asshole doesn't agree. So it's just understand, he does disagree entirely with Professor Lewin. I've already played the clip. I don't know what this show me thing is, right? You're the one not showing anything. You're the one who has zero evidence to defend your kinetic energy. Zero evidence to defend your notion, okay, that you can destroy momentum. I'm just saying, go ahead. Show me where NASA says F equals ma when it comes to thrust in space. Show me where they use that formula when they're talking about thrust in space. Yeah, of course he wrote F equals ma. But acceleration leads to a velocity. Again, net acceleration is velocity when you start at zero. When you're starting with objects that have no inertial, okay, momentum, obviously the net acceleration will be the net velocity. So they can't be separated. So again, on this occasion, there's no way to separate acceleration from velocity because you're starting from zero. I do believe in... Well, you overtly are arguing against it, because you can't believe in conservation of momentum and then say, I don't believe the half-mass object has to go twice as fast. Because that's exactly what Lewin said is required. That's what momentum demands. That's what conservation of momentum demands. So you haven't explained where the energy went, so you have no argument here. You can't say you believe in conservation of momentum, but you won't explain where the momentum died. Again, I'm not going to argue the word semantics, okay? It's semantics. F equals ma is semantics. The only reason the a is there is for the purpose of creating the perversion to defend Leibniz, and that's the only reason why it's there. It's clearly F equals mv. That's Newton's statement. You want it in a rate? You want to know what the rate is of a force? Well, then you put it over time. But if you don't need the rate and you just want to know the net force, you don't need time. I'll show you a single where they're never doing the equation for the net impact of the force. So just do it as a net impact. And I'm just saying there's no way to turn acceleration into anything else but a bizarre contrivance when you square it. Squaring a velocity is retarded. No, he did not say that. He did say that. So you're a liar. I mean, I've played Lewin saying overtly, you cannot finagle momentum. Nature can't finagle. Conservation of momentum depends on that if you have a 2 mass stuck with a 1 mass will be shot with half the velocity. Conservation of momentum demands that if you have a 2 mass stuck with a 1 mass, what the fuck does that even mean? Struck with a 1 mass, the 2 mass will be shot with half the velocity. What does that even mean? But it's exactly the experiment we're talking about. The experiment we're talking about is you have the same spring compression. You put a half mass on the same spring compression, it goes twice as fast. Isn't that what you're saying right there, you retard? Your argument is it doesn't go twice as fast, okay? You're saying the half mass pushed by the same spring doesn't go twice as fast. Lewin talked about springs stuck to a wall. What's the difference? I mean, whether it's stuck to the floor or stuck to the wall, what's the difference? I don't know what you're talking about. We're talking about an infinite mass on one side of the spring, okay, period. Doesn't matter what it is, just anything approaching infinity. And we're just trying to figure out how much energy goes into the other object, clearly. And that's what Lewin was talking about. And he was saying if you have the mass or double the mass, you have to have the acceleration. You have to decrease the velocity by a half. Oh, you're just, whatever. Wall, not another block. What the fuck? Again, it doesn't matter. We're talking about one side being mute because we're not going to let it move. So one side is going to be the same for both experiments. It's not going to move. It's not going to absorb anything from this thing happening on this side of the experiment. From its perspective, it's all the same thing happening. Yes, now we're back to pointing out that the acceleration is not velocity. Well, it's just a lie. The acceleration is the velocity in the end. It will completely change the velocity or create the velocity. That's all you can do. You can change a velocity or you can create a velocity. And you do it with an acceleration. So it's just a lie to say acceleration isn't elemental to velocity. Which isn't because they are distinct concepts, but again, details or precision doesn't matter to you. So again, yes, the details do matter to me and the precision does matter to me, and you're the one lying about what overtly Lewin said. You keep saying it's the how you calculate acceleration and velocity. How you calculate it isn't what it is. What it is an actual amount of speed that's measured by putting it in seconds and saying it's going 50 miles an hour or 50 miles a second. You put it in a number, and the number has to increase, okay, proportional to the mass number increasing. Okay, there's no special rules for mass, right? That just increases or decreases very simply. You're saying there's some thing here that happens with this acceleration thing where it isn't directly proportional to the velocity, that there's always a direct proportional relationship between acceleration and velocity. Of course there is. Any acceleration creates a velocity. You can't evade it, okay? You can't say in one case the acceleration doesn't create a velocity, in the other case the acceleration does create a velocity. That's complete bullshit. I mean, your own experiments prove you wrong, right? Because momentum is conserved by a gun. I shoot a gun, momentum is conserved. All right? It is. It's just a fact. So even though you have this silly idea that 2,000 joules flew out one end and only 2 joules went the other way, the fact is the momentum was conserved. I have 1,000 atoms moving 1 mile an hour going one way, and I have 1 atom going 1,000 miles the other way. So momentum is perfectly conserved. We're just talking about a spring gun now. And you're saying the spring gun doesn't do what the regular gun does. The regular gun conserves momentum. You're saying the spring gun doesn't. Now explain to me why the spring gun doesn't. You said the 2 mass has half the velocity. That's how the outcome of the experiment is. That's conservation of momentum. The bullet has 1,000 times the velocity because it has 1,000 times less mass. That's how it works. They're completely proportional, interrelated relationships. The same force will create the same amount of m and v. Okay, so does the same spring give more Ke to the mass? Again, Ke is irrelevant. We're talking about conservation of momentum. If it conserves the momentum, it has to give the object twice the speed. It has to leave with twice the velocity or you don't conserve the momentum. That's the simple argument. So are you saying it doesn't conserve the momentum and the half mass does not go twice the speed? That's the simple argument. I have a spring, just like a gun. I'm loading it with a charge. I'm pressing the spring down. I'm putting a force in. Now I'm going to release the force. You're saying the half mass doesn't go twice as fast. Explain where it went then. Explain why that's not a violation of conservation of momentum. The gun conserves the momentum. Why doesn't the spring conserve the momentum? Yeah, it takes only twice as long, right? The car will go, if we use the same force, the same, on this one, I've already been over this in so many videos, okay? It's MGT, it's not MGH, all right? 1, 3, 5, 7, that's Galileo, okay? It's really old science. 4 times the distance, only twice the time. I drop something from 4 times the height. It only falls twice the time. It's only in the gravity, the 9.8 meters per second gravity. The gravity happens per second. You get 9.8 per second. It's only in the gravity twice as long. Yes, it falls 4 times the distance. It's only in the gravity twice as long. It can only collect twice. It can only collect 2 units of 9.8. It can only create 8, the 19.6 or whatever. That's all it can create. That's all it can collect is twice the fucking velocity. 4 times the height, twice the fucking velocity. It's only twice the energy. So he keeps, now he's just changing. Is there a way I can contact you? I mean, fuck, my goddamn... Oh, you're trying to contact the other moron. Okay. Yeah. I will be 100% polite. Yeah, and doing what? I'd be very curious, Tim. So go ahead. If you can give away your email address, yeah, I'd be very curious what this fucktard has to say. This coward who can't send me the email. I don't know exactly where you said I called him a moron. I called you a moron, but whatever. It doesn't really matter. There's plenty of times Tim is a moron. Okay, just wait for it. Just wait for one of his moron comments. I just want him to answer the question. Max, whatever. Marx, Xer. Just answer the question. All right? You're saying the spring gun doesn't work like the regular gun. The regular gun conserves momentum. I'd almost argue the cork gun, the air pressure gun, conserves momentum. You're saying the spring gun doesn't conserve the momentum. Okay? I'm not going to get twice the speed. I'll get twice the speed. If I put half mass bullet in, I get twice as much velocity from the bullet. So I'm just saying, you're saying when I put the half mass in front of the spring, I don't get twice the velocity. Is that what you are saying? You said it doesn't work because you're saying its acceleration doesn't get into the object and it doesn't go twice as fast. You just said it, didn't you? Isn't that what you're arguing? I'm arguing it has to go twice as fast. Are you arguing for something else? It seems like you're arguing for something else. I'm saying the half mass has to go twice as fast. Do you have some other number? I can't believe it. Everybody who's right here witnessing this whole conversation by you, you're saying I'm wrong to say it has to go twice as fast. That was what you were saying. What mix and proposition? Haven't I... Look, everybody who's been watching me knows this has been an argument for 2 fucking years, retard. I've been saying the same thing for 2 fucking years. You have to conserve the momentum. To conserve the momentum, it has to go twice as fast. The gun makes it go twice as fast. In space it goes twice as fast. In all kinds of circumstances, it has to go twice as fast. So why, with springs, does it not go twice as fast? So just tell me, do you believe it goes twice as fast? The half mass leaves the spring twice as fast. Do you believe that? Or don't you? I'll block you if you don't answer the question. Do you believe the half mass on the same spring compression has to go twice as fast? Do you believe it? Yes or no? I'm waiting. So obviously if he won't answer the question, it's clearly he's just trolling. Okay. So he's made up all this whole fucking bullshit argument, and he agrees with me entirely that yes, the half mass has to go twice as fast. We're not doing this stuck to the wall shit, but it doesn't matter. There is no final velocity. It is not 2x. I don't even know what that means. There's no final velocity. Okay, so you're saying the spring is different than all the other guns. All the other guns will be twice as fast. But the spring gun doesn't work. Okay, so we got his answer. So at least that's an answer. So what's your answer? What speed does it leave with? I'd have to look at the calculations. Okay, well, you could just guess the MV squared thing sort of creates a 1.4 and a 7 relationship. So it would be 70% of the original velocity, what you would expect the original velocity to be. So it would be 70% of the 2 mass velocity. The 1 mass velocity, the 2 mass velocity would be either 1.4, in the case of going faster, and would be 0.7 in the case of going slower. So, okay, I mean, there's nothing I can say to you except you are making no sense, and you're clearly disagreeing with Lewin, because Lewin is clearly saying in his experiments that momentum has to be conserved. So, unless you're going to explain where the momentum went, you can't just say, yeah, it doesn't go twice as fast. Because Lewin says, clearly, in his own words, twice the mass, half the speed. That's his exact phrase. So, I mean, fuck you. Who's putting words in his mouth? You are. I mean, he does the calculation. Well, there's no point in... See, they can do the calculation either way. They can play with momentum when they want to, and then they can play with kinetic energy when they want to. And I played the whole video yesterday of Professor Lewin sort of mixing the two and pointing out that kinetic energy isn't conserved in all these experiments, that momentum always is. So, I mean, he didn't do the exact experiment yesterday, but he did experiments, and he basically was making the argument, okay, that kinetic energy is completely fudgeable, but momentum isn't. You always have to account for the momentum. You always have to conserve the momentum. So, I mean, it was the whole video yesterday. I mean, the day before. Do you agree that momentum is a vector? I've been over this so many times. All energy is a vector. There's no such thing as a scalar. It's baby talk. It's made up, silly talk. No energy ever scales anywhere. Okay, it's always got a direction, all the time, every time. Even if it's on a wave front. The vector for each portion of the wave is a straight line perpendicular to that wave front. All energy is a vector. No, it doesn't make any difference to understanding. You don't have any understanding here. It's an arbitrary word. You don't know anything about the history. Do you know who Leibniz was? Do you know what a soliton is and a monad? Do you know that the clay experiments done by Chatelet are with round objects being dropped into clay? And that round object, you should kind of tell you, hey, maybe the shape of the object has something to do with how far it'll get into the clay. That's all you have to defend 1/2 mv squared is nonsense. A religious theory by a kook, dug up by a little fake physicist who was tutored by a Leibnizian, okay, who sued her, by the way, for plagiarism. I mean, do you know anything about the story of 1/2 mv squared? No, you don't know shit. So scalar is just a made-up word. There's no fucking such thing as a scalar. There's nothing in the universe scaling its way across the universe. It's an entire baby talk distraction to make this pretense that there's the kinetic energy isn't, the train is coming down the track at 50 miles an hour, and you're going to pretend its energy isn't exactly in the same direction that the momentum is? That somehow its energy is in some other direction? It's doing something else than rolling right down those fucking tracks? I mean, yeah, we don't understand each other. There is a difference between our clinical understanding, our critical difference between our understandings. Yeah, I understand that to be absolute crap. Okay, that your kinetic energy can magically be a vector in any of these experiments. Every single one of these experiments has energy moving in a direct, straight fucking goddamn line. And it's just baby talk to pretend I have magical other energy that isn't doing that. I actually do want to discuss things with you over text or other media. You seem like a reasonable person. Well, why don't you find a comment section somewhere? Why don't you go to some little comment section and then you can do your little chit chat. So instead of saying you have 2 apples, I have to specify a vector. What does 2 apples have to do with anything? What does that have to do with the direction? What is the magnitude of a momentum have to do with the goddamn direction of the energy? They're 2 separate things. Okay. Oh, okay. If I don't agree with you, then I must be saying trains don't have direction of motion. You're clearly stating that somehow making your kinetic energy a scalar, whatever the fuck that means, somehow means it's not a vector. When of course it's a vector. You've exposed me. I have a fetish for kinetic energy. Yes, you clearly have a fetish for conventional theory. You're what's called a drone. Okay? You're called a Borgite, a dullard, a dupe, a fool, a sucker. Okay? You're all of those things. You're a little moron on your little Yankees bandwagon going, our team is the best. You're a fucking asshole. It was invented out of complete religious fervor. Okay, Leibniz is clearly quoted as saying in letters to his friends, okay, that Newton and Descartes are 2 atheists. These theories are dangerous to mankind. Okay, their physics is too atheist because God doesn't need to be in their universe. Because their universe is mechanical and runs on its own. Why not learn? Learn what? I'm not going to learn anything from you. Yes, you are all of those things there. Okay, good. You've conceded. That's all you're doing. You're just defending a theory you know nothing about. You know nothing about its origins, and you know nothing about the insanely weak evidence that defends it. It's in his letters. So, yeah, I don't have the link handy. I probably should have kept a record of all that stuff, but it's in his letters, okay? All his stuff is online. Go to Wolfram, has a whole giant reservoir of Leibniz memorabilia. Okay, but there's a website that actually has all his letters. He was meticulous about saving everything. So there's tons and tons and tons of that crap. But you could probably Google it. Just put in 2 atheists or just put atheist in quotes and then Leibniz, and you should end up finding the quote. I don't want to get into being on sides. Well, whatever that is. So it has some interesting perspectives, and I like seeing what I can learn from different points of view. Well, that's really kind of just mush talk, but whatever. I mean, a minute ago he was ready to concede that particle physics is kind of mushily founded if it's all based on this 1/2 mv squared, and now he's just kind of retracting and, oh no, I'm really wishy-washy now. But whatever. That's the way people come. In the end, there's a side. I'll just let you know, Tim, that the truth is that there either is mv squared or there is momentum, but they're not, both of them aren't real. Okay, you can't, both of them can't be real, because as Professor Lewin has demonstrated, both of them aren't conserved. So it doesn't work. You have to conserve one or you have to conserve the other. You can't conserve both. So they're already diametrically opposed theories. And again, it was completely defeated in Newton's time. In Newton's time, Leibniz lost the argument decisively. Well, you are lying. I mean, basically you're telling me that springs don't produce the same results as a gun. So all the other guns work, but a spring gun doesn't. All the other guns conserve momentum by conserving velocity. That is, mass and velocity. We're not talking about acceleration. We're talking about mass and velocity of the object leaving the gun. All the other guns conserve momentum. You're saying the spring gun does not. So I can make a magnet gun, conserves momentum. So I push into two magnets, and I create a force between the magnets. That gun works. Or are you saying that gun fails too? I'm not sure. So I don't have the experiment, frankly. But I'm just saying, what do you think happens? The half mass leaves at half the velocity? I mean, twice the velocity or not? Did anyone do the test where they stuck a gun into a wall, place a bullet and fire it, and then place a half-mass bullet in? Well, they have done the half-mass bullet thing, so, you know, that's a ballistic fact, I'm sure. So we probably can find that somewhere. That half the bullet mass means you get twice the muzzle velocity. I mean, you have to take out the bit of energy lost to rifling and the little bits of crap, but the general trend will be twice the velocity. So I have to show you experiments, but you don't have to show me any. Okay, I get that hypocrisy. So you don't have to show me it taking 4 times the fuel to go twice as fast. You don't have to show me anything. I mean, show me a Brozo experiment. I mean, link to that if that's going to be your theory. You know. I'm just saying that ballistic experiments are all over them. There's a ton of them online, so you can find those experiments. Did I ever say the car takes 4 times the fuel? I'm saying that's the direct statement by conventional physics. That's a fact in their opinion. Okay, that's what mv squared requires. It requires 4 times the fuel to go twice the fast, to move something twice the fast. Okay, because that's the energy requirement. To conserve kinetic energy, it must be a fact. Okay. Yes, they do say that, okay? So you can lie about it, but that's exactly what they say, and they'll use braking distance as an excuse for why, oh, it didn't work. You know. There's no point in playing a game. The fuel produces energy, okay? That's a fact, and the fact is, you know, whether you call it kinetic or you call it momentum, doesn't matter what you call it, it produces mv. Kinetic energy is made out of masses moving velocities, all right? So you can't escape that truth. All right, it doesn't function without mass and velocity. Those are the only constants in it. Those are the only real things in it. Everything else is a 1/2 and a square. Those aren't the real things. The real thing is the mass and the velocity. So you can't escape the mass and velocity requirements. The fuel has to produce the mass and the velocity for you to have the opportunity to square it. Okay, I'm not going to really argue with you, so... you know, this bullshit that I got something wrong. I didn't get anything wrong. Fuel obviously contains energy, okay, in a form. It's in a different form, okay? It's caught, trapped, stored, like a spring. It's stored energy. There's a difference between energy input to get from 0 velocity to some velocity versus maintaining. It doesn't matter. Do either experiment. Show me it taking 4 times the energy to get to 60 miles an hour than 30 miles an hour, or show me the inverse. But it doesn't matter to me. I don't care. Neither one happens. They're both wrong. Again, you want to argue about how the energy is stored inside of atoms. I'm going to argue that that's really gravitational energy in a lot of respects, but whatever. I'm not going to, who cares? We know the energy is in the fact that the thing is under pressure. Pressure is energy. Weight. The thing is being pushed into an atom with weight. Weight is pushing it. Okay, you can think it's being pulled together. I don't care what you think. The point is you're releasing a weight, a pressure. The former requires 4 times the energy. The latter requires you to look at the power equals force velocity, which varies based on how the force varies with respect to velocity. So again, he's just pretending he doesn't have to deal with the simple input and output. You have to deal with the simple input and output of the equation. So again, you're just playing a game, a bullshit game. You have to have 4 times the energy to go twice as fast. That's what your theory demands. 4 times the force. You have to acquire 4 times the force from somewhere. By your theory. You think gravity is linear. You think you use the same force going 1 foot as the second foot, the same third foot, fourth foot. Galileo figured out, no, it doesn't work that way. It's only 2 units of time, and in 1 unit of time you travel 3 times the distance, and you do the same work, doing that 3 times the distance that you do in that last 1 distance. The 1 distance is the same amount of work as the 3 distance. So obviously you thinking distance has something to do with work or energy you're bad. Galileo already proved that to be crap. So a guy living 500 fucking years ago was smarter than you are. Alright, let's see. Just know that not everything DS says is about Lewin mainstream physics, etc. Isn't 100% representative of what they actually say. So again, I don't understand. I play his fucking video. I talk about almost every sentence he speaks. I don't know how I could be any fairer to his argument. And some of these clips I've played over and over. I mean, I literally played, years ago, 40 of his videos all the way through. And somehow I'm not being fair to Professor Lewin? I mean, what a pile of shit. Especially when small details can make a big difference. Well, you seem to be ignoring the big deep details. Okay, that he's overtly makes the statement, half the velocity, twice the mass, half the velocity. Each bound formation produces a certain amount of kinetic energy. I don't know, whatever this is. The more bonds break would increase the energy. Yeah, what are the bonds made out of? I mean, this is just all bullshit. Look, we don't disagree about the fact that energy is stored in atoms. It's pressurized, there's energy in it, it explodes, the explosion is energy. The point is that you're saying, okay, that this energy, when it's in one form, when it's 1,000 atoms going 1 mile an hour, it's almost nothing. When it's 1 atom going 1,000 miles an hour, it's everything. I'm saying exactly the opposite. Those are the same thing. If those things came knocking on my door, it's the same thing knocking on my door. It's the same energy. One guy going 1,000 miles an hour, same energy as 1,000 guys going at 1 mile an hour. Same thing to me, not the same thing to you. God, there is no conversion. I mean, what the fuck that is means. There's no conversation. Well, yeah, no, there's no conversation with you. I mean, I think my points are being made quite clearly. I'm defending it quite clearly. I'm pointing out how you haven't demonstrated in 350 years of this stupid theory, you have no physical evidence of it. Again, in what context? Like, this is more bullshit. It's the same force. You're applying it. There's no context. We're saying what's the input, what's the output. We're not talking about a millisecond here or a millisecond there. We're talking about inputs and outputs. What's the thing, what's the circumstance at this moment in time, and what's the circumstance after the event took place? The change, the exchange, the touching, the contact. That's all. Pre-contact, after contact. Those things have to be conserved. There has to be just as much mass moving in that after effect that happened before the effect. So there's no point in talking about atoms exploding because we can't see the before. So let's just talk about real things moving and banging into each other. Newton's cradles kind of things. Let's talk about real things, and then you can explain to me how you don't have to conserve the fucking goddamn momentum. Stuck to a wall, stuck to the floor, what's the difference? The simple argument is if you have the same spring compression, you put a half mass on it, it has to go twice as fast. That's what Lewin was explicitly saying. You want to put words in his mouth? That's your business. If each spring produces 10 joules, again, joules are a made-up concept for you people. You just make up these numbers, okay? They don't have anything to do with anything real. You're saying there's 2,000 joules coming out of the bullet produces 2,000 joules of energy. You're saying the gun's recoil is only 2. If I do it in space, the spaceship isn't going to be turned. The spaceship is going to say it's the same momentum going both ways. Okay, one atom going 1,000 miles an hour, same as 1,000 atoms going 1 mile an hour to the spaceship. It doesn't see any of these joules you're talking about. These magical joules aren't going to show up anywhere. You're never going to do an experiment where you collect the joules as actual wattage of electricity, so you're never going to prove that the bullet has 1,000 watts and the other gun only has 1 watt. You're never going to prove that. You're just going to state it. So fuck you and your 10 joules. Double the number of springs, the joules double. So again, does this make any sense at all? That's conservation of momentum. It's not conservation of joules. Your argument is if it's the same mass, then it's 100 joules. Triple the number of springs, the joules triples. So again, just more baby talk. If you're increasing the velocity, that is completely wrong. So Moxers or whatever, why don't you tell Vertigo guy to shove it up his ass, because what he just said there is complete crap. Yeah, okay, because yeah, the 30 miles an hour velocity that you're going to create is going to create a squared function of joules, so you're going to have 9 times the joules. Okay, it isn't going to triple, it's going to 9 times. You are putting words into his mouth. He said acceleration was twice as much, not velocity. So again, it keeps lying that the acceleration isn't the net acceleration. Of course it's the net acceleration. So just keep lying. Well, I don't know how he could possibly be correct. If you add more force, you're going to increase the velocity. As you increase the velocity, you're squaring the impact of the increase in the velocity. Going 3 times as fast is 9 times the energy by kinetic energy. So you people don't even understand your own theory. Going 3 times as fast is 9 times the joules. That's your theory, you fucking idiot. I don't. Where did I equivocate? Amazing bullshit. Anyway, so it just proves my point, right? I mean, the people say it's not a conspiracy. This is clearly a conspiracy of belligerent stupidity. Yes, there's no conspiracy. They don't combine with each other, these idiots. They're just naturally, humanly idiotic. Okay, so even though the theory doesn't work, it doesn't make any sense. It completely breaks all kinds of static physics knowledge. I mean, all mechanical systems break down into nonsense because of these two theories. These two idiotic, this is wave-particle duality nonsense. You cannot believe in both of these things and be rational. Momentum is either a real thing or it's nothing, and kinetic energy is the truth, or it's the other way around. They're completely contradicting ideas. 3 times the velocity is not 9 times the energy. 3 times the energy. That's all you're going to get for your trouble is 3 times the energy. You're only going to defeat 3 times the gravity. Yeah, you might be going faster through the gravity, but that's all you're going to defeat. Because it's all about how long it takes you to travel through the gravity. I mean, I've already done that argument, but I mean, it's just so obvious that gravity is a time-dependent force. But anyway. If the fuel usage that I'm referring to, well, that's a complete sentence. The fuel usage that I'm referring to. Doesn't make any sense. You're talking about a spring and joules, and then you're saying the fuel usage I'm referring to. What the fuck are you talking about? You have to deal with the consequence of the application of the fuel. The point is that, you know, if you're not going to deal with those consequences, then what you're saying doesn't make any sense. Twice the dynamite makes the bullet only go 1.4 as fast, is what you're saying. Okay. If you believe that, okay. But I think that's as dumb could get. Again, it's conservation of momentum. You either believe in it or you don't. Once you believe in it, then kinetic energy is just nonsense. It doesn't need to pay any attention to it. So you're saying the same thing again. Because the acceleration is happening faster, it doesn't mean it didn't really accelerate. So you don't really get the velocity. You don't conserve the momentum. Hence, the velocity is not exactly 2x. What do you mean not exactly? We're talking about a huge reduction. Okay, 1.4 is kinetic energy's prediction. So 0.6 of the velocity is lost. So if you want to conserve your kinetic energy, it's 0.4. What do you mean by less than 2? I mean, if you want to sit there and say that there's tiny losses because the spring gets hot and, you know, the wall crumbled a little bit or some kind of bullshit, you want to make up some bullshit and say, okay, we lost a little bit of energy somewhere. Well, that's fine, but we're talking about 0.6 of the energy. We're not talking about a little bit of energy. We're talking about a gigantic pile of energy. To conserve kinetic energy, you have to destroy a lot of momentum. I mean, it's less than 2x. What does that mean? Again, what do you mean by less than 2x? You could just answer me. 1.9 what? 1.8? 1 point something? I mean, when you get to 1.4, then you'll understand who I'm arguing with. The people I'm arguing with say it's 1.4. Okay? That's what they're saying. I throw the 8-pound, the half as light bowling ball. I go to throw it, right? So I have a 16-pound bowling ball and an 8-pound bowling ball. I go to throw the 8-pound bowling ball, and there's something that physically stops me from being able to throw it twice as fast, and I can only throw it 1.4. That's their theory. That's what I'm arguing with. That's who I'm playing the Professor Lewin video against. They don't believe in conservation of momentum. I'm showing them that Professor Lewin does. By less than 2x, I mean less than 2x. Isn't that just amazing? I mean, what an evasion. You're talking about evasions. Could you evade any more perfectly than this? This is such a beautifully fantastic evasion. I mean, could you evade the simple question more evasively? By less than 2x, I mean less than 2x. I mean, that's just so special. A more precise answer requires a calculation. Why? Go ahead, calculate for me, please. Oh, please. Could you give me a range? By 2x, I mean 1.4. Or by 2x, I mean 1.9. If you say 1.9, then we don't have anything to disagree with, because I don't give a fuck about a 0.9, okay? I'll give you your 0.9. All right? But if you're going to say 0.4, I'm going to say, fuck you. A more precise answer requires a calculation with Newtonian mechanics. If it's Newtonian, then it's not going to have anything to do with mv squared, fucktard. You won't find Newton agreeing with that crap. So that's not going to work. You're not going to be able to lie about Newton. Newton's calculation won't have any squared velocity in it. So liar, liar, pants on fire. DS is saying if the half mass results in the same KE, yeah, yes, then under the KE theory, the velocity must be the square root of 2 or 1.4 the velocity. Yes, I'm clearly saying if you were going to conserve kinetic energy, then you're going to lose a lot of momentum. I'm saying then if it's a Newton equation, I'm saying do the fucking equation, because there's no fucking way Newton said it's 1.4. Newton opposed Leibniz directly, overtly stated, fucktard, he's an idiot, fuck him. Leibniz stole his calculus on top of it. Okay, so I mean he hated the guy's guts. He was his worst enemy in his life. There's no calculation that Newton did that has anything to do with kinetic fucking energy. Nothing. Newton's conception of velocity and acceleration was not your conception. Newton never said per second per second. Newton wasn't a fucking idiot. He wouldn't do something so retardedly redundant. Per second, 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 per second. I mean, you could do this infinitely, this per second thing. Now, it can only happen per second once. It can't happen per second twice. Newton wouldn't have squared the seconds on the acceleration. An acceleration was just like a velocity. It was just a certain miles per hour or a certain miles per second or a certain blah, blah, blah. But no square. I know what it means. I'm saying it's not a real thing. There's no sensible reason to square a velocity because something can happen more than once. How does squaring it mean it happens more than once? Or it can happen more than once? The very fact that it can happen more than once doesn't give you the right to square the velocity. I mean, there's no rational connection between the fact that it happens over and over again and the velocity. You would multiply the velocity times how many times it happened. If it happened 6 times, then you multiply it by 6. If it happened 7 times, you multiply it by 7. You don't multiply it by itself. Well, whatever. You believe in your infinities as you choose. So there's no equivocations in these videos, but whatever. You were just talking about units of acceleration, and now all of the sudden we're talking about velocity. So again, just playing the same game. You're obviously squaring, okay, a number by putting per second per second. The units don't get squared. You can't square a unit. You have to square the number you're going to place in front of the unit. So when you square the unit, you automatically square the thing in front of the unit. Durr. No, I don't agree anything about your distance arguments, because all your distance arguments are made out of bullshit. Okay, so there's no point in talking about them. I will state quite overtly that in space, if something's going twice as fast, it'll only go twice as far in the same unit of time. So that's all you're going to get. You're not going to get 4 times the distance. So in space, none of this crap means anything. In a real environment, none of this crap means anything. Okay, it's all about gravity. And as I pointed out, gravity is not mgh, it's mgt. It's about how long you're in gravity. If you're flying by a gravitational body, the faster you fly by, the less you get affected by the gravity. And the slower you travel by, the more you're affected by the gravity. Clearly a time-dependent force, not a distant-dependent force. You do not be affected by gravity per foot. You're affected by gravity per time. Per second. Not per second squared, just per second. Let's see, the time is squared in this equation. Are you saying this kinematic equation is wrong? Well, clearly, 1/2 times the acceleration times the time squared. Again, of course I'm saying that's absolute nonsense, because you're multiplying a time times a times anyway. Acceleration is already a rate in time. It's already got a time on it, so now you have time cubed. For fuck's sake. So of course I say that's absolute crap. So in gravity, do we have d? No, you don't have d. You don't pay any attention to the distance. It's irrelevant. You just have g and t. That's all you have. Obviously, they're in the mass. So if we say the mass is the same, we cross that out, and we're just saying whatever we do, gt is all that's going to matter. How much time is it in the gravity? Mass doesn't matter because all the masses travel the same speed, because they're all affected by a different amount of force proportional to their mass. So all of that's out of the equation. All you have is gravity and time. All you have is how many seconds were you free falling in the gravity. That'll tell you exactly how fast the goddamn thing will be going. Yeah, well, I'm giving him his shot. You know, this is I'm just pointing it out. This is all there is. This trolley crap is the only counter argument you get, and this trolley crap built on, well, it's less than twice as fast, but I won't tell you how much less. Height equals, again, I'm not playing the height game. Galileo already proved the height game doesn't mean anything. Okay, it's 1, 3, 5, 7. So depending on the height, the distance, the amount of gravity you're going to be affected by is radically changed because you're moving through it so goddamn fast. The faster you move through the gravity, the less gravity affects you. It's not about a fucking height number. It's about a time. And that's it. I'm not evading. I'm just telling you, you want to get the mv squared answer, yes, you do it your way. You want to get the right answer, you do it my way. Clearly, in gravity, if you're going twice as fast, you will go 4 times the distance. In gravity. So whenever gravity is creating the opposing force, or the propelling force, it's going to be 4 times. There's going to be a squared relationship. But it's only because of gravity. That's what gravity does. That's not what all the other forces in the universe do. So I'm not evading anything. I'm just overtly telling you, if you want to get the right answer the quickest way, it's MGT. Well, I'm not evading anything. Just lie. I'm not talking about MV squared. You're mixing top. What are you talking about then? That's what that is. I'm sorry, when you multiply a time and you square it, that's mv squared. T squared is the same thing as velocity squared. You're just replacing velocity with time and squaring it. So what the fuck's a squared time again? And what the fuck does that mean? How the fuck does that make any geometric sense? How could you possibly turn that into a Pythagorean theory? How could you show us the mathematical origins of the time squared? And I'm literally trying to do the same thing, asshole. I mean, clearly, I don't think you understand motion at all. You don't understand that it is conservative, that forces push matter in the universe, and that's all there are. There's just masses moving, period. If I want to know how far something travels, I have to use d, or height. Yeah, if you want to know how far something travels. And I'm saying to you quite overtly, twice the energy, 4 times the distance. So I'm telling you, yes, of course. But that's only because gravity is time dependent. It's only affecting you like a spray gun. If you want to figure out how much spray is going to hit the stuff you're spraying, it's the same inverse square law. So yeah, it works. Okay, you can figure out that there's 4 times the effect. Okay, I make a light twice the distance away from me, I get 4 times less photons. All right, that's the way it works. That's the relationship. It's not linear. It's not connected to each other directly. It's by a squared function. But that distance has nothing to do with a representation of its energy. It's not telling you how much energy it has. It doesn't land with 4 times the energy. 4 times the height does not produce 4 times the weight. It produces twice the weight, twice the time, twice the fucking goddamn weight, twice the fucking goddamn velocity. So again, I'm telling you overtly, if you want to go with distance, you'll get the wrong answer. It's not 4 times the energy. Because it's only twice the time, it's only twice the velocity, and it's only twice the fucking weight. How can you call that 4 times the energy with all those goddamn 2's yelling at you? All those 2's. 4 times the height, twice the velocity. 4 times the height, twice the weight. 4 times the height, twice the time. And you're going to tell me it's 4 times the energy. Well, I'm going to say, fuck you, your equation is nonsense. Well, I mean, you know, there's no point in having the conversation. Just fuck off. Do I say anything about energy? I mean, what the fuck do you think this conversation's about? You're saying distance is a representation of energy. Clearly, that's what you're saying. Distance matters. Distance is important. If it goes 4 times the distance, it must be 4 times the energy. That's the overt statement in your mathematical representation. I'm telling you, quite obviously, I'm telling you there's no relationship directly between distance and the energy, in the sense that it's an illusion, okay? Because the distance will be greater the faster you're going. Obviously, something's going faster, it covers more distance in the same amount of time. And it's not a linear relationship. It's a 1, 3, 5, 7, 9, you know, on and on relationship. And I told you overtly it's not a valid equation, because distance, you're representing distance as meaning something. I overtly said there's no point in multiplying the distance time my goddamn thing, because the distance isn't telling you the truth. It's not representing anything real. Well, again, you can't concede that if I told you, yes, that equation is correct, it's basically saying distance is energy. I'm clearly saying no, distance isn't energy. So if you want to say the distance isn't energy and you'll concede you're not using it for that purpose, fine. Fine. As long as you don't make that equation equal energy, then we don't have a problem. Okay? Besides, I don't give a shit about the distance. Distance doesn't mean anything. But if you're going to say the distance represents the energy, then we're going to disagree. Because that D number will get bigger and bigger and bigger the faster I go. The more distance I'll cover in the same time. Well, it does matter. So you say it doesn't matter. I say it matters huge. I'm explaining why yours is a mathematical gimmick. And you're pretending there's no gimmick. Well, that's your business. I can't do anything about it. I'm saying distance doesn't represent energy. You're saying it does. If something's rolling, right? The same argument made. I roll it with twice the velocity. It goes 4 times as far. Why does it go 4 times as far? Well, it goes 4 times as far in, guess what, only twice the time again. And guess what? It only reaches half the velocity when it's 3/4 down the track. So half the velocity happens way over here, not here, way over here. So it doesn't start going half as fast until it gets way over here, 3/4 of the way. It's telling you, quite obviously, that the distance is not rationally connected to the energy. I mean, it is rational. I'm just saying you have to understand that it's happening because of the fact that the force is now friction, and the friction is being controlled by gravity, and gravity is a time-dependent force, so it's only in 2 units of friction. The 4 times the distance was only 2 units of friction. The validity of something does not matter on how it is used. Well, I'm not going to argue it. Of course, it has everything to do with how you're using it. Oh, yes, something is either true or not true. So again, I just explained how it can look like I could have 2 circumstances where I roll something. And in one circumstance, it reaches half its speed halfway through the voyage, and in the other circumstance, it doesn't. Well, those both couldn't happen in gravity. One of those would have to be some other kind of friction, some other linear friction. So a linear friction happening because you have little things sticking out and they rub against something. Some other way to create the friction, you'll only get twice the distance, because you will lose half the velocity through half the voyage, because you'll be having the energy taken from you at the same rate all the time per inch. Gravity doesn't take the energy from you per inch. Gravity takes the energy per second. Gravity gives you the energy per second. It doesn't give you the energy per distance you traveled. Well, you're just talking ad hominem, wishy-washy, self-aggrandizing nonsense. I actually believe in objective reality. We obviously don't agree on what objective reality is, because obviously I would argue that I'm exactly doing that, and you're exactly doing the opposite. You can argue with kinetic energy formula isn't the best representation, but it's still correct. But it is still correct. I don't even. You can argue that the kinetic energy formula isn't the best representation. What are you talking about? No, I can argue that there's no evidence for it, and it's nonsense. It's absolute made-up religious kookery. It's a piece of aggressive religious theology shoved in the middle of your physics. That's how non-objective it is. All right. You apparently don't. Where did I use ad hominem? It's ad hominem to claim you're clean and I'm dirty. Okay, if I walk into a room and say I'm cleaner than everybody else, I'm clearly arguing that everybody else is dirty. Okay, so that's an ad hominem, fucker. Kind of obvious, fucker. All right. You made much more ad hominems than anyone here together. No, I didn't. I mean, I could call you an asshole. I believe you're an asshole. I can call you an idiot. I believe sincerely you're an idiot. They're just factual statements. I'm just describing the factual circumstance. I believe you are a dupe and a fool, okay? And I believe you are a bandwagon riding drunk asshole, okay? He just believes it because somebody told you so. You don't believe it because you understand. Again, did you do any research? No. Do you know who Leibniz is? No. Do you know where this kinetic energy theory came from? No. So go read the history and then tell me about how, yeah, I'm really supporting the good guys. Because you'll figure out you're supporting absolute fucking goddamn toxic crap. It's silly, stupid nonsense. And it broke a perfectly rational universe we lived in. Galileo, Descartes, and Newton showed you the truth. They showed you this crystal. You can look right through it and see. And you're just smearing mud on it. You fucking idiot. I think you both guys agree. I think this will be more, this is where Tim loses it. I think you guys both agree you have to bring something 4x the height to get 2x the velocity. Well, I'm just saying, isn't that right there telling you distance doesn't have a motherfucking thing to do with it? I mean, well, obviously distance can't have anything to do with it. It's not proportional. All right, I was making an inference based on what you were saying, an inference, not an ad hom. You think equations' validity depends on the person. Well, I don't believe that at all, so fuck you. So it's a lie, and it's an insulting lie. So you can call that not an ad hom. It's a non-ad hom, in my opinion. That's just shit talk from you, okay? It's falsely premised. I can point out that there's no way I can agree with an equation that says in all circumstances it's gravitational. Every single circumstance of motion in the universe is gravitational motion. Gravitational motion is a unique case. It's a specialized force that's time dependent. Every other force is not time dependent. Every other force does not happen like gravity happens. Most of them are instantaneous type forces. Most of them are bang, I hit you and that's it. There's very few forces that go on for billions and billions of years pushing on something exactly the same. So I'm just saying your application of this theory to the universal theory is the one that's broken. I'm not saying the universal force is gravity. I'm saying the universal force is just momentum, the idea that you move some object and it takes energy to move the object. Let's see. You do the same by claiming you're more clean than everyone else. Well, whatever. I know who Leibniz is and where it came from. I know everything you talked about and more. Well, if you know more, then why don't you tell us more about what's a soliton and what's a fucking monad? Why don't you explain what those things are? Do you think it matters what shape an object is when you drop it into another substance to absorb its energy? I mean, do arrows go into objects easier than non-pointed objects? Whatever. I don't contradict myself, but whatever. The fuel consumption will increase exponentially. So whatever that means. It's exactly the opposite, by the way. The faster you go, the more your fuel gains more. Your fuel gets more octane in it. The faster you can move your gas tank, the higher you're increasing the octane of your fuel, ironically. Another thing that Professor Lewin points out, and he points out how, boy, that sure doesn't make any sense, does it? It's the way it works, but yeah, it doesn't make any sense, does it? Because the explosion produced would act on the axle for less time, because it is moving faster. So again, that doesn't make any sense, just absolute rubbish. The pressure is far in excess of the outcome pressure of the gearbox and all the rest of that crap. So there's absolutely no way you're outrunning your pressure source. Why are solitons and because they were relevant to Leibniz. They were his fundamental understanding of how momentum and energy worked in the universe. He called it the living force for a reason, because he believed the force was alive. It had a soul. It's hardly a non sequitur. When a guy calls something the living force, okay, and you're talking about physics, and he's basically implying that it has spirit powers. That's not exactly, this is a guy in his youth who believed that if you hit a pea into a giant boulder, both the boulder and the pea would leave at the same velocity. I mean, he believed some wacky fucking shit. That's relevant to me. If that's the physics you're believing in, that's a relevant point to make. That your physicist that invented your great idea that nobody else had, in my opinion, was a loop-de-doo kook. Also, I know that this would blow your worldview apart, but momentum does not equal force. Well, you can keep saying it, but Newton said it directly. But so, fine. You say it doesn't work that way. I say it always works that way. Every fucking experiment ever conducted will prove it works that way. Lewin doesn't say momentum is energy, okay? So yeah, obviously Lewin's an idiot. He doesn't understand that these two theories are in competition with each other. He thinks they're somehow compatible, that you can believe in both. I'm just saying, don't argue non-arguments. The argument is Lewin does believe in conservation of momentum. So don't pretend he doesn't. I'm saying I wish we could ask Lewin, okay, what he meant by, twice the mass, half the velocity. What did he mean by that? Why do spring guns fail to work and regular guns do work? Regular guns conserve momentum. Spring guns don't. It'd be nice to ask him these questions. Yeah, well, whatever. You aren't correcting anything. Show me a source saying he connected kinetic energy to monads and solitons. I'm just saying he believed in monads and solitons. That was the nature of energy in the universe. It wasn't made out of electrons and masses and all that kind of stuff. It was made out of these things, monads and solitons. Something moved because it had solitons in it moving. I don't have to back it up. It's in his own literature. It's his theory. Again, he called it the living force. Vis viva. That's what he called it. Well, look up. Oh, so you said you know everything about it. I don't know how you could not know anything about solitons and monads. It's all. It's his entire philosophy was structured around the existence of solitons and monads. It's in all of. I mean, it's almost disgusting how tainted everything is by these silly words, and you're like, what the fuck is he talking about? It's in all his writings. It's all over the fucking place. There's a nut in that stupid John Chappelle Society, that Bill Lucas guy. He believes in these solitons and monads. He's a real Leibnizian. And a real religious kook, by the way. If it's all over the place, I should be easy for you to provide sources. Well, I'm not going to provide them in a chat. I'm sorry, I don't go out on the internet while I'm trying to interact with people and all this kind of crap. So that's your game. You want to play that game. I've done plenty of videos on Leibniz. It's all on Wolfram. Go to Wolfram's page. Wolfram has a whole page on Leibniz and all of his inventions and what a great guy he was. And even he just kind of brushes over the whole soliton and monad thing and basically just says, I don't know what the fuck that shit is. Yeah, you won't be able to make any sense out of it, so it's probably no reason to connect it. I'm just pointing out as this is the source of Leibniz's understanding. Okay, his understanding was this simplistic. No, it doesn't explain the connection. Nobody can explain the connection, but I'm just saying the connection is in the understanding. You don't understand the difference between somebody understanding what an electron and a proton is versus somebody who doesn't understand what the atoms are made out of, what mass is. So understand, Leibniz and Newton and all these people, they didn't know what electrons and protons were. They didn't know all this kind of crap. So they had to account for what mass was and what energy was. So Newton clearly made a distinction between the visible masses moving and the invisible forces acting. Leibniz's distinction was the force was in the soliton. It was in the mass. The mass was the soul. There was no ether, so to speak. There was no something mitigating. There was just the solitons communicating. So your claim is either fabricated or you're changing your claim. I'm not going to argue this with you, okay? You don't think it matters what this guy thought elementally about the universe. I'm saying clearly that was his motivation. Clearly he didn't like Newton and Descartes' physics because it made the universe look like a machine that doesn't need oil, that doesn't need God to show up and fix things now and then. And he didn't like it at all. A vehicle needs 8 times the engine power to reach twice the speed. So where do you make this up? Okay, but whatever. It's 4 times, but whatever. Whatever. Engines aren't perfectly efficient, so obviously it's a bad example because, you know, the combustion engine loses 15%, you know, with each increase in your demand from it. So obviously as you're increasing speed, you're going to, as you double and quadruple and quadruple the speed, you have to lose that 15% with each increment. So you're losing a lot of energy. All right, in principle, we're talking about more direct comparisons. And frankly, that would only increase my argument that you need even more than 4 times the fuel to go twice as fast. In ideal circumstances, you need 4 times the fuel to go twice as fast. In real circumstances, your kinetic energy would require that it fail even more dramatically because you would have to take engine inefficiency into account. And so then you would need 5 times the amount of fuel to go twice as fast. So, well, whatever. You're not even close to being on the right subject, Vertigo guy. Virgo. That is the standard explanation. You can say standard, quoting who, link to what video. Where does anybody say this crap you're saying? So, fuck you. Why is it v squared instead of v cubed or v to the 4th? Was it just a guess? No, it was completely related to gravity. Again, you're so goddamn stupid. It was clearly just because of gravity. He thought everything should work as gravity works. Gravity is Leibnizian energy if you go by distance. So if you say 4 times the height, and, you know, that's got to be 4 times the energy, right? But it's only twice the velocity, and it's only twice the weight, and it's only twice the time. So he didn't care about anything Galileo discovered, okay? And he was just basically going by the distance. So he was saying, I hit something twice as hard, it ends up going 4 times as high. So he's saying it must have 4 times the energy because it went 4 times as high. So it was just making the mistake of thinking everything works like gravity works when nothing works like gravity except for gravity. I mean, you could argue that hydraulics, what do they call it, turbulence, what's the science of water flow and airflow, that those things have some similarity in the sense that you have to have a friction coefficient. You have to have something that connects you to the stuff, or the stuff to push you or to pull you along, and so it's not a linear relationship. It's not a directly linear relationship. The coefficient breaks down, so the faster you can go over the water, the higher you can rise above the water, the less contact you have with the water. You can change all of that so much. So there's not like some standard theory you can use to say how fast does something move through water. But I'm just saying in most cases we're not, I'm just saying I don't know what to say. It's gravity. It's the way gravity works because of the fact that it's this time-dependent force. It's a pushing force. It's a particle force, and that's why it affects things this way. It depends on how much mass you have. The more mass you have, the more force you collect, the more weight you'll have when you hit the ground, the more pressure you'll put on the ground. But 4 times the distance is only going to get you twice the weight, okay? I drop something from a distance and it weighs something. I drop it from 4 times higher. It only weighs twice as much. Its instantaneous weight will only be twice as much. I mean, a paint sprayer duplicates it. So if we use a spray that's a particle spray, I'm going to spray sand. So I'm spraying sand on something, okay, at a constant rate. All right, then you'd probably get the same results as you get in gravity. And you use mass as size. So I just change the size of the objects, okay, make them the same mass but change their sizes. So one gets hit by more than the other one gets hit by. I mean, there's a way of duplicating the same kind of circumstance where you'll get 4 times the distance with only twice the energy. But the only reason why you're going to get 4 times the distance in friction, again, is because it's gravitational friction. If you absorb the energy in some linear way, some way that is per foot, not per time, right? So that's the whole point. Gravity is per time, per unit of time. It's not per unit of distance. 9.8 meters per second of force, not 9.8 meters per meter. So, but that's why Leibniz argued the point. And that's all he argued. He only made gravitational arguments. He didn't show any experiments. He didn't do any experiments. He just said 4 times the height equals, 4 times the pressure. There's no experiments to defend it. He just asserted distance was energy. And therefore, it has to be 4 times the energy, even though it's only twice the weight. I mean, it's too bad these people couldn't live at the same time. It's too bad Galileo, Descartes, Newton, Leibniz weren't all the same age, and they could have all these arguments in the same conditions and all that kind of stuff. I mean, Newton was a little bit older than Leibniz, I guess 20 years older, 25, maybe less than that. So they were sort of co-current, but Galileo, Descartes were all, misaligned. I don't know, Descartes and Galileo, I don't know how similar they were, frankly. Yeah, I don't remember dates too well, so. But obviously, I think Galileo would have made very strong arguments against Leibniz. I mean, he really would have pointed out that you can't use gravity because it doesn't work that way. 4 times the height, it doesn't weigh 4 times as much. It can't possibly have 4 times as much energy because it doesn't weigh 4 times as much. It doesn't hit the ground with that much 4 times the energy. It just doesn't. Well, I don't want to argue. I mean, it's a difference between force and energy. Of course, I've said it over and over. I had it in the title of these videos. Force equals energy, equals weight, equals momentum, equals heat, equals everything. Everything moving, a mass moving is energy, and energy moving is energy. Energy is the stuff free in the universe, little tiny things, little bits of fucking energy moving the speed of light. And everything else that moves because that shit moved it. Okay, that's it. There's energy pushing stuff right now. Right now, there's energy occupied pushing electrons and protons. And then there's energy, like photons, flying through empty-ish space. Okay, and that's it. That's it. That's all there are. So there's little bits, little BBs moving the fucking speed of light, and everything else just either has some bits stuck to it or no bits stuck to it. That's it. But you really can't make a distinction. I mean, if you're going to say force isn't energy, then what the fuck is it? Energy says energy? I mean, it's just too silly. Of course, force is energy. Of course, momentum is energy. Of course. Things don't move spontaneously. They only move because something caused them to move. Something had to give them energy. It had to give them velocity. It had to give them the force. The ability to push on something. The ability to move from one place to another and impact something. I mean, what you really need to make a distinction between is not force and energy. You need to make a distinction between matter and energy. Mass and energy. Mass has no energy until energy impacts it. By the way, if force is not energy and energy is not momentum, does this mean your entire theory is wrong? Well, I would say, of course. If you can come up with a fucking experiment somewhere where force doesn't equal energy, whether you can make free energy without a force, or you can make a force happen without creating any energy, using energy to make the force. But yes, of course. I mean, yes, of course. If you can prove there's not two things in the universe, matter and energy, okay. Go ahead. Prove that wrong. Show me one experiment that demonstrates that to be wrong. There's no experiment I can't explain as being either energy moving freely, photonic energy, radiation, or mass moving that's being pushed by force, being pushed by bits of energy. I mean, I should have the simulation in the background, frankly. Because that should be the context. I mean, it's all, this is where it starts, this is the beginning, the end, the story, this is the story. It's just these objects, electrons and protons, being pushed in a field of energy, which you probably can't see very well, which is unfortunate. Let's see if I can make the energy big enough where you can see it. Let's see. Force bit radius, no. Oh yeah, that's the one I want. Okay, so that's this down here, and 15, that's really big. Yeah, really big force bits now. That's all there are. There's just the stuff moving, and it sticks or it bounces, and that's all it does. It sticks or it bounces, sticks or it bounces, sticks or it bounces. That's all you need to create all the matter motion in the universe. You don't need anything else in the way. That'll do it. And according to you, if you have a 1 kilogram mass going 1 meter a second left and a 1 kilogram mass going 1 meter per second right, the total momentum is 2 units. Yes. Because obviously in this circumstance, there's two things moving in the fixed frame we're using. Both things are moving. And it doesn't matter whether you say it's 0 or I say it's 2. The point is when you add it up later, you're going to add it up right or you're going to add it up wrong. So if you add it up right and left, both being momentums, it'll be perfectly fine. Momentum never subtracts or cancels when adding in a system. Yes. Cancels is a tricky word. I'll say it has to go somewhere. So it never cancels. You never destroy momentum. So yes, it always has to go somewhere. So I'll explain where it goes. If you make an inelastic collision and the two things stick to each other, just like Leibniz, and Newton, and Descartes, and Galileo, I'll speculate that the energy's still in the object. It's just you can't see it. So all of them figured out the heat argument. All of them, to some extent or another, pointed out that if two things crash into each other and you have no motion after they crash, that the motion's still there, you just can't see it. In your simulation, make one mass collide with the two mass. There's no reason to double masses in my simulation. Okay, nothing is in this but electrons and protons are in that real universe. I think you will be surprised what the force bits do. Liar. Yeah, there's not going to be any surprise. It's an accountable force. It's a fixed amount. It's going the speed of light. It never goes any other speed. Each force bit always has the same momentum every time it hits something. It can never have any other kind of momentum. So there's no difference. There can't possibly be a difference in the answer. The answer will be exactly half the speed. If the thing is twice as heavy, it'll take twice as much energy to move it. I'm not all that informative when it comes to physics, but it's really not that hard to understand that there really isn't that much going on when things are moving in space. Well, space does clean it all up, but you still have to be outside of gravitational influences for a lot of these experiments to make sense. But clearly in space, if I use the distance formula, right, then something going twice the speed isn't going to go 4 times the distance, is it? No, it's not. It's only going to go twice the distance. No matter what time interval I use, it's only going twice the distance. It's not going to roll 4 times the distance. Because everything's going to roll 4 times the distance. Everything's going to roll forever. So you won't be able to use that cheat, of absorbing the energy with this fake friction, this uneven friction. I mean, the very argument that I have to even make the argument that friction changes with speed. The faster you go across this scale, the less you will deflect the scale. The slower I go, the more the scale deflects. The faster I go across, the less it would deflect. To a theoretical maximum where I could go fast enough where the scale wouldn't even be affected. The fact that I have to argue in defense of that theory, yeah, that friction obviously isn't the same for all objects. Obviously the same amount of energy does not go into the ground for all objects going all speeds. It is not a per foot friction. It is clearly a per time friction. Gravitational friction is not linear. It is clearly proportional to speed. The faster you go, inversely proportional to speed. The faster you go, the less friction. The less energy you lose to friction per foot. Same energy per time, not the same energy per foot. Clearly showing gravity is not distant controlled, it's time controlled. The force is a function of time, not a function of distance. Alright, so we're well over, almost hitting 4 hours. That's kind of amazing. I didn't think I'd do that. But I did it. So, just the fact. Alright. So, not much progress beyond just showing, that this argument is silly. In the sense that they've had 350 years to prove their theory, and they won't. They won't do the experiments. They won't provide the volume of evidence. They just keep arguing that they know it to be true, and they must be true, and it has to be true, and we all say it's true, and that's why it's true, is because we all say it's true. And they won't provide the logical information. They won't provide the ability to recognize. I'll keep saying it's 2 times the time, it's 2 times the velocity, it's 2 times the weight, and they'll keep telling me that's 4 times the energy. And I'll keep saying, how can I possibly make 2 times the time, 2 times the weight, 2 times the velocity into 4 times anything? So anyway, till the next time and such and so forth and whatnot. Incredibly long stream, yes. Hopefully I'll never go back to those, the Stickham days where it'd be 12 hours later and I'd still be in the room arguing. Oh, fuck. That was so bad. No. Some of that was fun, though, I have to admit. Did have some entertainment value. Anyway, till the next time and such and so forth.